Welcome everyone to JavaOne 2026, or rather to the live streams for JavaOne 2026. Glad to have you here. We're gonna do streams today, tomorrow, and Thursday, 8 a.m. our time, which is whatever this time is your time. And we're gonna do a bunch of different things. Today we're gonna talk a little bit about Java 26, and then in half an hour we're gonna have the Java and AI keynote for you. And after that, we're gonna have Chet Arimura here talking to folks from NVIDIA so they can present you the latest ideas. Tomorrow we'll focus in more detail on certain things that are in Java 26. We're going to dive deeper into garbage collection, into Head of Time. I've talked to Brian Getz. We're going to play a conversation with Brian Getz about the the carrier classes proposal that he had. So we're going to look a little bit into the future there. And then on Thursday, Billy and I will be here to have a little bit of an unconventional pre-show. We'll see how that goes. And then after that, we're going to have the community keynote here from JavaOne. And then, of course, if you're interested in any of the talks, they will also be released here on the Java YouTube channel over the next couple of weeks and months. As usual, we'll take our time to make sure you get to see all of them. And I'm not here alone to celebrate this day. I'm here with Mikael Vidstedt. Hi, Michael.
Hello, Nicolai. Glad to be here.
Yeah, thank you. So why don't you introduce yourself real quick for those who don't know you?
Sure. I'm Mikael Vidstedt. I am Senior Director of the Java Virtual Machine. So I've been working my whole life with JVMs, and I now run the Java Virtual Machine development team.
Okay. So I got like important forks here.
Yeah, well, yeah, it's fun technology. It's been my life, right? And I like every single day of it. Always a new challenge.
Yeah. So we're gonna talk. We're gonna run down the list of JDK enhancement proposals in Java 26. And contrary to popular belief, I don't actually know them all by heart. So I have my phone here. So we go through them.
Cheating.
Yes, I'm cheating. Exactly. And right. So. As usual, there's a mix of JEPs in there, right? Some of them cover, that's more like your strong suit, right? Like the JVM internals. And then we have language. There's not that much there. There's a continual preview. We have some APIs that are coming and that are being evolved. And then also we have things, and that's the first JEP, where things are going slowly away. So it says the title is "Prepare to make final mean final."
Ah, yes.
So what does it mean? Like why does final not mean final already?
Yeah, exactly. This is actually one of those things that fascinated me when I started working on JVMs many years ago now, decades ago. We all know that there's a final keyword in Java, right? And if you slap that in front of things, then surely things are immutable, right?
Yeah.
And working on the JVM, I was fully under the assumption early on in my career, right? Like, surely we can make use of that in the JVM and optimize for it, because if it's final, then it can't change. Yeah. And it turns out that the truth is slightly different from that.
Yeah, so the reflective APIs can actually change. Like there's this famous call we call set accessible true. Like you use the reflection API to get access to a field, and then you call set accessible true, and then final doesn't mean final anymore at all. And
exactly.
Yeah.
So that means that the JVM can't make use of that assumption, and that means, unfortunately, that you're not going to get the best optimized code even if you have the final keyword in front of your field.
Yeah. And I think what is indicative of how the whole, because this is under the umbrella of integrity by default, because Java language promises you something, but it also delivers tools to undermine that promise, which is that performance is one aspect, but there's also this maintainability aspect of if push comes to shove and something really weird is happening, you must consider the possibility that final doesn't mean final. So something like correctness or maybe even security could be impacted in your program, and because you cannot trust this by default. And that's what this is about, right? Nobody's going to take the reflective API away. It just means that it will by default not be able to make these changes. And there will be command line flags, or there are command line flags now.
Yes, and I think it's a warning now in JDK 26, is that right?
Yeah, right. So there's a two-step process. The intentional long-term solution to this is by default, the reflective API will not be able to do this, and you use -- enable final field mutation to allow specific code to make those changes. But then the question is, what about all the other code?
All right.
Because at the moment, all code is all the other code. And so there's another flag, which is illegal final field mutation, which has different settings, which allow you to say this to get warnings or to deny it, which I would recommend now. So if people have the chance, enable what is intentional and deny everything else. But if you don't do that, this flag will basically be implicitly on warn, which means, yes, you'll get a warning if that happens.
Yeah, exactly.
But you can tune it up to deny, which I would recommend. Maybe first doing testing, but to make sure that you know where this is happening.
That's right.
Yep. Next one we have is to remove the applet API.
Oh yes. Oh, brings back memories.
Yeah. So this took a long while. Have you ever talked to like Stuart maybe for why this took so long?
Not about that specifically, but I will say that the applet API is like I'm going back in again in my career and my life, right? And I'm pretty sure that the first Java application I ever wrote was probably an applet, right?
Yeah.
Back in the mid 90s or so.
That is true for me too as well. I haven't thought about it. Yeah.
Yeah.
That's like late 90s or maybe early 2000s. I'm not sure. Like it's 99 or 2000 when we were in high school. After like a year and a half on Turbo Pascal, we did some Java, and it was indeed applets. Yeah, true.
Yeah, exactly. Yeah, no. So, but clearly, as we all know, applets have they had their purpose, served their purpose, and they served the purpose really well back in the days. And of course, nowadays, not really. Yeah. But part of the reason why it's taken so long is obviously that people are relying on that API in the background, right? Not deliberately necessarily, but it accidentally pops up in many different places in the JDK.
Yeah, I was going to say, because when you said people, that's absolutely true for the JDK itself, right? Yes. So the JDK itself was one big user of applets in cases that were unrelated. Like they were using applets as a tool for something else, and that's something else had to replace, and that's why Dr. Deprecator, I'm not sure why I said Stuart, that's why Dr. Deprecator took a while to make the final cut, but he did. And in JDK 26, the applet API is gone.
Yes.
Which should not impact anybody realistically.
Yeah.
Except maybe some demos or something.
Exactly. It's been deprecated for a while and has not done anything for a while. So now it's truly gone. So indeed. Yeah.
The next one, that's probably one that's up your alley. Ahead of time object caching with NEGC. So let's go into what ahead of time is, and then we're going to take it from there.
Yes. Okay. So in a nutshell, ahead of time is the ability to run your application once in a training mode run, and then capture the state, and not the application state, but rather the sort of the JVM state, loaded classes, things like that. And store that in a file, and then in subsequent runs, you point the JVM to that file, and you magically get better startup time and warm-up time.
Yeah. And I think it's important to point out that even though we're going to talk about JCs, which feels like, stuff on the heap, this is not at all about application data. So it's not about that something from your training run, like, instances that you created in a test or whatever. None of that is in this cache.
Correct.
But there's still stuff in the cache, though, that belongs on the heap.
Yes, indeed. So there are two sort of distinct different types of data in that file. One is what we call sort of native memory, not on the Java heap, but rather memory or data on the side. Yep. So that's class related and all that. But yes, there are indeed objects that are going on the Java heap inside of that archive as well. As you said, not at the application level, but rather things related to classes, their names and things like that. So
instances of like the class has instances for every application class,
right?
And those, for example, are on there, right?
Exactly. Yeah. So things like that, and so they need to live on the Java heap. And one of the challenges we have is that the GC, the garbage collector, is very opinionated about the layout of objects on the heap.
Yeah.
So as probably everybody knows, there's a small header associated with every object, and so the GC has opinions on how exactly what the object should look like, the bit format, but also where it should be stored in memory, for example. So that varies a bit depending on which garbage collector you're talking about. And one of the challenges we had in the past here is that archive, the file that we create on disk, is GC specific, right? Like the whole purpose of it is that you should be able to load it and use it, right? Yeah. But the way we did that in the past was to really store it in the GC specific format.
Yeah.
And so what this JEP does is to make that more flexible so that you don't have to. This is like, there are many pros and cons with this sort of, but like the obvious pro is one of usability. So instead of having to create different archives for different garbage collectors, you can like create one big archive, and the VM takes care of just when it loads the data, do that in a way that fits the GC that is being run.
And importantly, that's an additional option, right? Because as you said, there are trade-offs. The old format could just be memory mapped, which this one cannot be anymore, needs to be actually streamed, so that requires some CPU. And also the ups and downs depend a little bit on whether it's a cold or hot start. The JEP goes into all details on that, so people should actually check that out if they're interested in this.
Yes.
One more thing that we should maybe mention, guests I'm really looking forward to, will be for the podcast, though, later at JavaOne. I'm going to talk to Martin Chalupa, and then also from Netflix, and also John Rose here from us who's working on the Leiden team, to have more insights into how Netflix is losing Leiden and what their needs are. And we're going to record a podcast there. And they're also giving a great talk here, which is called Drawing the Rest of the Owl, which I only know with the swear word in the middle there, drawing the rest of the owl. And so, which is like, okay, look, we talk about this stuff and we put it in JEPs, and then they have to like draw the rest of it and like, make it work. And so I'm really looking forward to that talk as well, to see how that works in practice.
Yeah, it's exciting stuff. The whole ahead of time or product lighting, as you referred to it as. We've been working on it for many years now, and we're really starting to see the benefits delivered now.
Yeah, and it's like basically every release had something recently, so that's really cool. Like, you can still push things too,
and significant improvements. Try it out.
Yeah, absolutely. The next one is the HTTP 3 support, and that's kind of funny because, like, I had this perception. Well. Like the surface, at least, I knew that there's probably some implementation down there, right? I'm aware, but the surface level of that is super simple, right? So if you use the HTTP client API, you can already specify the version, and now you have an additional enum value, which is called HTTP 3, and that's mostly it.
Yeah.
And then I was kind of like, I was a bit dismissive of that, like, well, that's not too interesting to talk about, right? But it turns out that there's actually so much more than meets the eye. HTTP 3 does not use TCP; it uses QUIC, which is based on UDP. Which meant there were a lot of RFCs to implement. This was a gigantic amount of work that the networking team did there. And we had a podcast about that where I talked to Daniel Fuchs and Daniel Jelinski about this. So that one, they went in depth there. But one thing that is important to know is that since you cannot upgrade a connection from HTTP 2 to 3 because it does use a different protocol, like there's some trade-offs between what version gets selected.
Yes, exactly. How do you know that the server you're going to talk to actually supports HTTP 3, right? And you don't, is the answer, sort of, unless you have previous knowledge.
Yeah.
So there's a bit of a trade-off. I think there are 4 different variants of connections. Yeah, right.
And so they explain, like, how do you trigger which one? Yeah. And one thing that would be nice, though, that I get asked occasionally is, well, DNS has records on this now. You can ask DNS about that. But that's something that I asked also the Daniels about, and they said, well, the way that Java does DNS is through the inet address classes, and they do not have the capabilities to expose this kind of additional record, like these informational records. And so that would require a decent expansion or rework of that API, which is never something that can be just trivially done. So not sure when that's going to happen.
I guess it's worth pointing out here that we're talking about the HTTP client as well. So there's no, as far as I know at least, there's no server implementation in Java yet for HTTP 3. Is that right?
That might absolutely be right. I'm not aware, actually. I didn't check. Yeah, no, that makes sense, though. Because
I think it's in the title that is for the
exactly,
client.
Exactly, the JEP is HTTP 3 for the HTTP client API.
There we go.
So yeah, that makes sense.
Yes.
Thanks for catching that. Next one. That's another one for you. G1GC, improved throughput by reducing synchronization. The title is already, I have to scroll vertically to read the full title. So what's up with that?
Yes, this is an interesting one. So G1 is our default garbage collector for, let's call it most configurations. We're working on making it the default for all configurations as well. But in JDK 26, let's say for most configurations. And G1 from the very start is designed to have a good balance between throughput performance and pause times or latencies. And over time, we've worked on improving both throughput and pause times. And then a few years ago, we started talking about the fact that, well, throughput is still lagging behind a bit where we would like to see it. And we started exploring various ways of improving on that. And we even discussed having a specific or a separate mode of G1s, like you really have to opt in with a flag to get a throughput mode for G1. Now, in the end, I think our conclusions here, unfortunately, sort of we ended up here, is that it's not worth it to have a separate throughput mode. As a matter of fact, that makes it more complicated for users having to pick between the different modes, but also for us having to test it and develop and maintain that.
Yeah, I can imagine, yeah.
So what we found was that with relatively simple means in the background, sort of, we could actually improve significantly on the throughput performance at the cost of some additional memory. Like the age-old trade-offs in computer science, right?
Yeah.
The good news here is that the amount of additional memory is very small. So I think it's like 0.2% of your heap or something like that.
Because you're duplicating like a data structure that keeps track of stuff, right? And the data structure is apparently not that large.
That's right. We call it the card table. It all gets very technical very fast. But in effect, exactly. The application is sort of helping. It's not like you're updating your Java code, but when we JIT the code, we inject some snippets of code in the background that help the G1 collector keep track of what's going on, how the heap is mutating, how things are changing. And indeed, one of those structures now got sort of duplicated so that we can more easily handle it in the background, let's say, and improve on throughput.
Yeah, so for those interested in that, we're going to have, in pretty exactly 24 hours, I'm going to have Stefan Johansson on, who worked on that. And we're going to have about 15 minutes to dive a little bit deeper and understand what's the write barrier, how does synchronization play into that, what's that card table, how does it work, and so we can understand better this improvement, what I like about JEPs like this is that Java does a really good job at abstracting things away. Unless you are very interested in performance, you usually don't need to know that kind of stuff. And that's fair, right? Like that's good. Like it's good that as a Java developer, I don't need to know everything that's going on under the hood because there's a lot going on under the hood. But then the JEPs, when something changes because they were written and they give some context, they are an opportunity to learn that stuff. They're just on the side. So what I do tomorrow with Stefan is absolutely not required reading to be able to use JDK 26 or even benefit from this feature because there's no knobs, there's nothing. It's just background information to better understand what's going on, which I not only find thrilling, I would also argue can come in handy, but it's definitely more of a nice to know than a need to know.
Yes. Yeah, no, that's true. I think for many of the JVM JEPs that we do, is they're more informational, not in the JEP sense of information, but informational in the sense that we're just highlighting things that we did that few people will have to ever care about because it's just there and works.
Yeah. And also like the JEPs in general, like they're basically architecture decision records, right? I think they just provide value to the Java ecosystem and also to the OpenJDK community just by being there, by having this amount of like information poured into them and also the diligence with which they were written.
Indeed.
Yeah. The next one is PEM encodings for cryptographic objects. They were going to now go into preview stuff. That API is in its second preview. And do you use GitHub yourself still?
Yes.
I used to programming.
I do.
Do you even live, bro? So do you even code, bro?
I do interact with GitHub, yes.
Okay. Did you ever upload a key?
I did.
So you know, like the little text block.
Yep.
That's the PEM stuff, right? That's my main and maybe even only interaction with it that I know of.
I have a few of those very similar use cases, let's say, but yes, indeed.
Yeah, because I hear that they're like used, like they're really, like again, the JEP explains that really well. They're used for all kinds of, basically where humans have to transport this information, right? Where I have to give my key to some tool.
And you don't speak,
I
don't
speak binary.
You don't speak binary.
Exactly, yeah. And a PEM encoding is, the binary representation of a cryptographic object turned to base 64 string. And then there's this header, -- begin, whatever this is, certificate or PGP key or something. And then there's an end block. And Java had all the buildings, or has all the building blocks to handle that. But they're just cumbersome to use, right? If you want to create this encoding, it's kind of okay-ish. You can turn the cryptographic object into bytes, and then you can do the base 64 encoding, and then you can put the header and footer there. The other way is more cumbersome because you have to figure out which one is it, and then trigger the right kind of parsing. And so different ways to do this. There's like parameters that can be embedded in this representation. So that's quite cumbersome. And the PEM API makes that really straightforward by combining all these pieces together.
Nice.
Yeah.
I feel like I need to go use it now.
Yeah, it's really straightforward. That's nice to use. Yeah. Actually, so the JEP contains PGP key, I think, or certificate. So what is that? Yeah. And I'm gonna let the audience find out. Now it's pretty easy. You can just go to the JEP, copy that, and say then PEM decoder off, decode that string, and then you get back, and then you see what it is.
Awesome.
Yeah. I'm not trying to continuously tease other content, but I will keep doing it just because it's really thrilling for me as well to be here, to be able to talk to all these people that are my colleagues, but it's not like I hang out with them a whole lot, given that there's we're continents apart. Yeah. So even you only see every couple months for these streams.
That's right.
And this is an opportunity for me as well as everybody else in the community to grab these people and talk to them. And one thing I talked to Sean Mullen yesterday a whole lot about all kinds of security work in JDK. And one of them was about PEM, actually. Yeah.
Yeah, we like talking about what we do because it actually is a lot of fun, right?
Yeah, it's fun to you too, yeah.
And especially, again, on the JVM side, a lot of what we do is transparent. So, again, nobody technically needs to know, but it's still cool to talk about it, right?
Yeah.
We're doing good stuff.
I assume that there's a certain pride in having done some work and we all want to yap about it. Yeah.
Why not, right?
Exactly. The next one is structure and currency, which is in the 6th preview, why is it 6 previews? Why are there many previews sometimes and not?
Yeah, so obviously, when we as we all know, right, the Java specification is one where when we bake things in, they're going to be there for decades to come. So it's important to get it right, and obviously for a thing like structured concurrency, we do want to iterate on it and really make sure that we fine tune and make sure everything feels good, right? That we're confident that it's the right APIs and it's working the right ways before we finalize it in the end.
Yeah. And one critical ingredient that is feedback, right? The reason why, it's not the only reason. But one reason why some things take longer than others is maybe because there feels like a little bit more of uncertainty on the teams developing that. They do their best work and they're basically saying, okay, this is the best we can do right now. But maybe we feel like there's a little there that people could try out. And so the amount of feedback that comes in is a factor in how many previews there will be.
Yes, and I think for a thing like structured concurrency as well, not everybody is going to be using structured concurrency. Like it's a sort of a low-level primitive, right? Like thread synchronization and doing things. At least it's still that, right?
Yeah, but I'm not so sure about that because I think so basically on the order of, I would say, structured concurrency initially will be used in the same order of magnitude as thread pools, which makes them not common, not everyday code, but it's not exactly rare either. Right. So every time now you would submit something to executor service, you maybe in the future will have structured concurrency block there. And then one could argue, because they are so easy to use, virtual threads are so cheap, maybe we're going to do that more. Basically, every time you say, oh, I have two things I'm going to do at the same time, don't even think about it. Structured concurrency, new task scope, fork them off, collect the results, anytime, everywhere. Given that, the rest of the program has to then deal with concurrency. That part is true. But the threads themselves are cheap enough that you can do that.
I fully agree. No, I think it is a shift in mindset that threads are all of a sudden dirt cheap, right? Use them. There's no reason not to. So yeah indeed. I think that's changing.
I think I picked it up from maybe Ron at some point in the past. I'm not sure though. Maybe it was Alan Bateman. So I really like this idea of like, so how many threads can I have was a relevant question. And now that question is about as meaningful as how many strings can I have? Yeah. Well, all of them, hopefully, as much as you need. But once you do run out, that's when you have to start caring, right? Like you don't usually, in most applications, you don't start by counting out the strings you will be able to have. You just create them whenever you need them.
That's right.
And that's pretty much the same with virtual threads. Of course, because they do use the underlying actual threads, you will see, you will not scale infinitely, but that's not what it's necessarily about. It's about being able to use concurrency whenever you need it without worrying that just by the fact that you're trying this, you will overload the system.
Yeah, exactly.
Yeah.
Do whatever is natural for your code. Like to have the freedom and the flexibility to express it the way that makes most sense.
Yeah.
Indeed.
Yeah. And so the structured concurrency API has seen a considerable rework in JDK, at least at the surface level, in JDK 25, because the functionality of it, the virtual threads, and the way that this works, that's like 90% or 95% of the feature is, again, under the hood, and that's stable, and then nothing changed there in the last years.
That's right.
It's just, in quotation marks, the surface. Yeah. How can we expose this functionality in a way that makes the API that makes this functionality best to use?
That's right.
And so in JDK 25, there was a rework by pushing a bunch of configurable stuff into this joiner interface. And in 26, one of the changes was that joiner got an on-timeout function. For example, so now the joiner will learn when the structured task scope timed out, and then it can do stuff. Maybe it needs to clean up something, whatever. And so, yeah, that's the next preview. But the change from 25 to 26 has been minor.
Yep.
So I'm really hoping that we don't have to see a seventh one.
Fingers crossed.
Fingers crossed, exactly. So JDK 26, as I said, didn't actually say that, did I? It was released earlier today, like 2 hours ago or something.
Yeah.
I kind of missed saying that. Yeah, okay. Yeah. So JDK 26 already out.
Yes.
The JDK engineers are working on Java 27 for like 3 months now.
Uh-huh.
But I observed that JEPs being filed for the new release. So in those, a release gets 6 months, right? And there are 3 months shifted versus, the work on them is shifted versus the publication, because the last 3 months of each release cycle is let's make sure everything's fine.
Stabilization, ramp down, yes.
Exactly.
Indeed.
And that means feature work is only the first 3 months. And that means that when Java 26 now is released now, but it was forked 3 months ago.
That's correct.
And so from that point on, the mainline went to 27. So the mainline has been on 27. So OpenJDK engineers, unless they were involved in stabilization, have been in 27 mode already for like 3 months now.
That's right.
But I observed that those first 3 months, not a whole lot of JEPs get filed.
Yeah, and it's sort of natural, right? Like because obviously we're still like we could stabilization surely mainline, like we're trying to keep mainline very stable at any given point, but people are still occupied to some extent ramping down and stabilizing JDK 26 in this case, right? So they don't have as much time to work on features. So there is a bit of a lag, sort of just naturally.
Yeah. So I'm looking forward to what gets filed now. Maybe structured concurrency. Maybe there will be a JEP that maybe it's already draft. Actually, it's right next to this page. We have time there. I might check it out.
Right.
Another API that sees another preview is lazy constants, which touched on something you mentioned earlier. You talked about final, meaning final, and about you didn't say constant folding, but you were alluding to constant folding, which this ties into.
That's right. So again, being the JVM person I am, I do want to make sure that we optimize the code. And of course, make sure that it runs like securely and correctly and all of that. But in the next step, with good performance as well. And one of the things that the JVM can struggle with in some cases is really sort of look through all the complex structures, and especially as we touched on earlier, the final stuff, which isn't always final, right? So that's a bit annoying. So in addition to, so lazy constants is a user level API where you can lazily compute values or initialize fields, let's say, right?
Yeah.
But so it's a way of just saying, I don't necessarily need this initialized when I create the instance or the class, but sometime later when I access it.
Yeah.
But what it also allows us to do is the JVM can look through all of that. So once it's initialized, we know in the JVM that it actually really is initialized and it won't change.
Yeah.
And we can optimize for that then. So like actually make use of whatever value it ended up
and
having in the end.
And that's important because that's like I can create a lazy class like the one that is there that has the same API. It gets a little bit challenging when concurrency gets involved, but you can get that right. But getting that second part, promising the JVM that this will never change once it's initialized, and then it can be constant fault and can be optimized. That's something that we can't, because you guys refuse to make the stable annotation public.
Right, yes.
So there's a notation within the JDK that marks these kinds of things, and it's probably private for good reasons.
Yes, I think it's not a great API. Like the annotation, stable annotation is not great for general development, let's say, right? You want something more explicit. So
but it is becoming unnecessary, right? Like record fields can already not be reassigned. Value class fields, Valhalla's value class will also not be able to be reassigned. But they're both final, but they're really, really final. So they could also never be changed to reflection. Static final fields couldn't be changed to reflection. Regular classes, instance final fields will soon not be able to be changed to reflection, and then none of them can. And then basically all are stable.
Yes.
Plus minus.
Exactly.
Some details, yeah.
Yes. So it's really unifying the story about stability and immutability there, which is nice.
Yeah. Then we have the 11th preview of the Vector API, which there's nothing to add there. The Vector API they need identityless classes. There's a lot of, to get the performance that you want out of the Vector API, they need identityless classes. There's here some special casing at the moment for this prototype to work, or for this preview to work. But, no, it's not a preview. It's an incubator, importantly. It is an incubator, it's not a preview.
Yes.
Which means it has a different package name, and it's much more likely to change. And instead of merging it with this special casing, it just wants to wait for Valhalla, get the identityless stuff from there, and then it flows downstream. And so I asked, is it likely that once value types go into preview, which there's a decent argument to be made that this might be in 28. I'm not going to put you under the gun. I'm just going to this is my personal.
I know better than to answer that question anyway.
It's my personal hopium that it's going to be 28. But the Vector API might not preview at the same time, just because there's so much going on with Valhalla that maybe it will be like a release all too longer until vectors can tag on that. That would then make it 2027-ish sometimes. Let's just hope. The last one is, I think, the only language feature that is currently like going on at all, which is primitive types and patterns.
Ah, yes, right.
That's in the fourth preview. Yeah,
fourth preview. Yes, yeah. No, that's also exciting stuff. Making switches and all that more flexible and allowing you to express extract the fields and all of that in a much more compact and reader-friendly way, I guess.
Yeah, and one thing that this is really good for, if you have evil APIs, for example, give you like a nullable, like a boolean, like a capital B boolean that might be null. You can now, it's very easy now to switch over that boolean. You go case null, case true, case false, which is, it's not great. Don't get me wrong. Like having a tri-state boolean is the work of the devil. But when it does happen to you, it's really handy now to deal with that. So I think I framed this as it's sort of like rebalancing the language. It's not that these features are like game changers on their own, or they can come in really handy. It's more that it would be weird if you can pattern match on references and there's so much power there. But when it comes to primitives, it's like, you're back to Java 4 or something.
Yeah. I like what you said, because this to me is one step in many on a very long roadmap that I know John and Brian brainstormed in a conference room in Santa Clara at some point, meant 10 years ago, right? And we've been churning, constantly delivering incremental improvements in almost every release since, right? So it's nice to see that this is still ongoing.
Okay, so that was everything that was in Java 26. On the surface level, you're now aware of everything that's going on. If you want to learn more in detail about any of these, then, as I said, some of those topics we're going to touch on tomorrow on the live stream. We will also have talks about many of these topics coming out over the next couple of weeks. You can also go to dev.java, go to the Java YouTube channel. There's info about all of this all over the place. You can just read the JEPs yourselves. They're a great read. We will very soon go to the keynote right now, which is going live. And you might see a little bit of a loop while we carry the bits from one place to the other. So please don't leave us. And until that does happen, though, do you want to say a last word on performance work in 26? Because I know there's always little tiny things.
We always continuously improve on things in the JVM, and one of the things that we obviously spend a lot of time on is performance. I don't have any numbers up my sleeve at the moment, but what I can say is that one of the challenges we have is, this is a good thing ultimately. We do a release every 6 months. That means that we rarely have fantastic, huge improvements between 2 releases. But if you go back to JDK 25, JDK 21, or even JDK 8, right, the performance has improved a lot. So try it out.
It piles up. Okay, look, I think we'll go over to the keynote now.
Please welcome to the stage Oracle's Vice President of Java Developer Relations, Chad Arimura.
Hello and welcome to JavaOne 2026. We heard there were some weather issues and some airport issues, so we hope your travel was smooth. Thank you for making it and enjoy the California sun. For those who changed your plans and couldn't make it, we hope you're enjoying the live stream. But I just want to say that there's a student here in the audience that drove 10 hours straight yesterday from Idaho to make it today. So that's commitment. All right. Let's jump right to the elephant in the room. There's something that's really captured the hearts and minds of developers everywhere. Something that's changed the way we think about systems, about software, and about delivering the future of applications. Something the media just can't stop talking about, and my social feeds are full of hot takes, some of them annoying, from world-changing to world-ending. That's right, I'm talking about Java 25. Why are you laughing? Java 25, released just 6 months ago, heralded in a series of headlines that really capture the moment we're in and the progress we've made in the platform over the past couple of years. And we agree, Kate, sorry you couldn't be here, but Java 25 does make Oracle cool again. We have a lot to talk about today. We're going to talk about Java 26, and we celebrate the release this morning. Can you believe that Java 26 is the 17th release in the 6-month release cadence? That means that we've been releasing a new version of Java every 6 months like clockwork since 2018. That feels like an era ago. There's a ton to talk about, but before we get there, we have a special treat for you. Cult Repo, a film producer, has been working on a documentary on Java, and we want you in the room and on the stream to be the first ones to see the trailer. Let's roll the clip.
You can think of Java as a performance in multiple acts.
The story of Java is the greatest story of all time.
For me, it was just 4 letters and a cup of coffee.
The whole world is going to land on the network. We just believe that as an article of faith.
And it was either ubiquity or go home.
I've heard Java be declared as dead more times than I can count.
There were a lot of people out there at the time who were very, very skeptical.
There is no tomorrow. There will not be Java.
If this had been discovered, we would have all been fired.
We had to totally redo the foundations.
Java's second act is the world domination phase.
It took all of these good ideas that were already floating around in the ether, and it made them mainstream. It gave them to everyone.
Everybody is interacting with Java every day, all the time.
It's well constructed. It's proved its worth. Don't mess with it.
Okay, expect the full documentary this summer, and I put this slide together to will into existence a premier red carpet experience here in the Bay Area. You'll all be invited. Okay, let's get back to Java 26 and more confetti. So, like all releases before it, it's fully production ready and ready for you to upgrade your applications today. It's not just a bag of random features, though. Every feature aims to improve developer productivity or program performance, or possibly both. And many of the features are parts of larger feature arcs that span over multiple releases and build upon what came before it and hint at what's to come. These feature arcs include 1, making Java more data-oriented and functional. 2, making Java easier to learn, easier to teach, and easier to write small scripts and small programs. Number 3, always improving the throughput, scale, and performance of the runtime. 4, always improving the integrity of the platform. And finally, I have made it this far, but of course, we're ensuring that Java is the best platform to do your AI and agentic workloads. Now, I want to say one thing about this. We don't have a crystal ball. We don't know exactly what's coming. I had conversations last night at the speakers' dinner, and pretty much everybody's got an opinion on it, but they're all across the board. But one thing we all agree on, and one thing we're all here, is because Java literally powers the world. It runs on 70+ billion devices. It powers trillions of dollars of transactions every single day. It's used by almost every one of the world's largest companies, literally almost every single one of the world's largest cloud providers, many of them are represented here today, many of the world's largest nation states. It truly is, remarkably, one of the most successful technology stories in history. Maybe you've heard me say that before. But it's also an incredible human story as well, as it's touched the lives of so many over the past 3 decades, as we hope it's touched many of yours. This conference has always been about both the technology and the people. In fact, we have a keynote on day 3 that's dedicated to the people and the human element called the community keynote. And we encourage you not to miss it. But in a world where it's becoming harder and harder to tell what's real and what's not, what's human and what's not, we think it's more critical than ever that we're there for one another. We're there to open doors. We're there to champion one another. We're there to be Jug leaders and Java champions. We're there to mentor others. This is critically important. And we have one more video to share with you that I think really captures this notion of the human element of creativity, ambition, adversity, and achievement. So I want to welcome you one more time to JavaOne. We're going to roll Arsiini's clip, and I'll hand the stage over to George Saab. Thank you.
Hello everyone at JavaOne in California and on the stream. My name is Arsiini. I am 13 years old and I am from the frontline city of Sumy, Ukraine. I am proud to be one of the youngest certified Java developers in Europe. My passion for programming started back in 2nd grade when I first experimented with Scratch and Python. That was the moment I realized I didn't just want to play with code, I wanted to truly understand it and build real technology. I chose Java because it's one of the most powerful and widely used programming languages in the world. It's used to build web and mobile applications, enterprise systems, and complex software products. While studying Java, I learned how to think systematically, design classes, and apply object-oriented programming principles. Programming helped me develop strong logical and analytical thinking skills. Java opened the door for me to create real-world projects and grow as a developer. I am very grateful to my teacher, Serhiy Shiryakov, who helped me deeply understand how Java works, especially at the JVM or Java virtual machine level. Thanks to his guidance, I learned how to analyze code, find efficient solutions, and confidently prepare for certification. I also want to thank my mentor, Arsen Malashevsky, who is helping me master the Spring ecosystem through the Noodle program. His support and motivation push me to improve every day. If I could give one piece of advice to other young coders, it would be this: never give up. Even when things are difficult, even during war, keep learning, keep building, and keep experimenting. Find mentors who challenge you, stay curious. If you truly love what you do, no goal is too big. I see my future in the world of technology, growing as a Java developer, working in a team on complex projects, and creating my own products. Best regards to you all from Ukraine, and happy JavaOne.
Please welcome to the stage Oracle Senior Vice President, Java Development, George Saab.
All right, good morning. And wow, wasn't that fantastic to see Arsiini, right? How exciting. I remember myself when I was young and learning to code, that feeling of excitement when you did something and it worked. And we want young people today to have that same experience when they come to Java. So that's something that we've been working on. In fact, it's something we think about every day as we work on Java. So with that, we're bringing you Java 26, as you can see, a wealth of wonderful JDK enhancement proposals, all in 26, 10 of them. But and those really kind of span the works. It goes from the language to things in the VM, improving performance, improving security, and also cleanup that helps make things better as we're moving forward. But we should always remember it's not just these things that are exemplified in the JEPs that make the next version of Java great. There are also hundreds of smaller features, bug fixes, enhancements, and so it's worth taking a look at those also and seeing what kind of improvements those will bring to your programming experience. We always like to thank all of the people who helped bring the release about, both from my team here at Oracle as well as around the ecosystem. And I'm pleased to say we're going to have a couple of the folks on this list here later today, later in this keynote, in fact, NVIDIA and Microsoft. So we'll look forward to that. But in the meantime, I wanted to talk a little bit more about things we're doing to make the programming experience great for new learners, for students, for teachers. So you may have heard of the Java Playground. If you haven't, please check it out. And I'm pleased to say we've updated the Java Playground today for JDK 26. Now, this is a wonderful place where you can go. You don't need to download a new version of Java. You can try it all out directly in the browser. But, maybe when you've gotten a little bit past that, you're starting to want to use a more full-featured IDE. And there are certainly great ones of those for Java. As an example, IntelliJ and VS Code, a very popular one among students. And if you're using VS Code, we can recommend that you try the Oracle Java extension for VS Code. And this is a best-of-breed extension which allows you to basically use the same code paths that are used for Java-C in order to do your programming advice in VS Code. And we think this is exciting. In fact, we also have done some work in order to make it so that you can share little snippets of code and basically go when you have a little example, maybe a teacher can share it with students, students can complete it, they can send it back. And we think this is going to bring a new versatility to the programming experience for learners. Now, in addition to that, we know notebooks are very popular, and I'm very pleased to say that we've done some work in order to allow you to have notebook support for Java directly from this environment. So please check that out as well. Very exciting. Okay, so as you know, the team at Oracle who are working on Java don't just work on the JDK. We also have a number of libraries and frameworks and tools that are quite popular for when you're using Java. And so we've had a lot of people who have said to us, we really like these, but we want more. We want actual support to be available from the Oracle team for these. And so I'm very pleased to say that we're now launching something called the Oracle Java Verified Portfolio. And this is basically a program that's going to allow you to get support if you're a subscriber for Java from Oracle, or if you're running on the Oracle Cloud Infrastructure. And this means that you don't just have to go and file a public bug and hope it gets fixed. It means you have a professional team that's standing behind it that will make sure that your issue gets dealt with, is dealt with privately. And in order to do this, this is something that we think will grow over time. But the initial packages that are included in that are JavaFX, the Java Platform Extension for VS Code, and Helidon. Now I'm going to tell you a little bit more about each of these. So you're probably aware of JavaFX as a fantastic toolkit for writing graphical user interfaces. It's been around for quite a while, and it's enjoyed commercial support from Oracle for the Java 8 version. But I'm very pleased to say that going forward, they're moving up and are going to be embracing the tip and tail style of development that we use for the JDK itself. And we'll be offering you commercial support on all of the different releases that enjoy long-term support from Oracle. So please check that out. Similarly, we're going to be providing commercial support for the Visual Studio Code extension, the Java Platform extension. And I'm also pleased to tell you that we're going to be offering that for Helidon as well. So what is Helidon? Many of you may be familiar with it as a best-of-breed microservices framework. It's something that historically you could get commercial support for if you were a WebLogic customer. But going forward, you're going to be able to get it if you're just running Helidon. Now, this is a nice one to check out because of all of the frameworks that are out there, and here once again in the Java ecosystem, you have lots of choice, which is fantastic. But Helidon have done a great job of looking at what's happening in Java itself and letting you take advantage of new Java features as they become available to you, right? And even embracing the use of those features in the microservices framework itself. So when virtual threads were added to Java, Helidon was basically the first one that came out and said, we're embracing virtual threads, we're going to use it, we're going to allow you to do this style of programming, and they have gone on with this. So we're quite excited to see where this is going to go because Helidon are going to be aligning the release cadence with the JDK's release cadence, doing true tip and tail development. This means when Java 27 comes out, you're going to have Helidon 27. When Java 28 and 29 come out, you're going to have Helidon 28 and 29. And for all of the releases that enjoy long-term support, there will be a long-term support line for Helidon as well. This makes things very simple for you as a developer or an organization that wants to use this because you don't have to worry about different versions and what goes where and I need this feature. It's like, no, it's just very, very simple. You want to use the latest, you use the latest version of Helidon with the latest JDK. You want long-term support, whatever version you need, there's going to be a version of Helidon that lines up on that. And to further raise the bar here, we are planning to propose a project in OpenJDK for the future evolution of Helidon, meaning that it truly will be aligned with new development that's happening in Java as it happens, letting you use those latest features as soon as they come out, but also thinking through in advance, how can those be brought to you at the microservices level? And in fact, that's, I think, going to be amazing. Another nice thing that we're announcing is commercial support for Helidon through the JVP that I mentioned earlier. So please do check that out, and there will be some fantastic sessions on this during the conference as well. So while mentioning OpenJDK, did anyone catch the latest project that was approved? So something called Detroit. This is basically a project for people who want to combine snippets of JavaScript or Python with Java. This is something that we see is very popular. People have been asking us for this as they want to do things like take maybe AI libraries in Python or maybe some kind of snippet that they have in JavaScript and combine those two things together. So Detroit is a project that actually got started a few years ago and was kind of put on ice. And one of the reasons it was put on ice was we realized that there was a bunch of work on the foreign function of memory API coming from the Panama project that it would make a lot of sense to use here. So now that that work is done and available, it made sense to bring this back up and give you a fantastic way of combining the best of breed runtimes for Java, for JavaScript, and for Python. You don't have to worry about it being some weird different implementation. It is the implementation you're probably using if you're using JavaScript or Python, and certainly of Java. Now you can use those together. Okay, so as you can see, we've been moving Java forward with an incredible amount of momentum. We're making the runtime more efficient. We're saving you and your organization time and money. We're adapting the language to new use cases and making it easier to learn. And basically, we're continually improving and trying to make sure that the ecosystem is keeping up as we're going along, but also securing your applications from a growing number of threats. And of course, finally, we've been looking at Java and AI. We're excited about this. We think that Java is basically the best platform out there for AI workloads. Our stewardship of the platform is primarily guided by a couple of key values: readability and compatibility. And these values are key when it comes to AI. So basically, these have led to some of the best specifications, docs, APIs, feature proposals in the industry, and that gives AI the structure that it needs to produce great results. Finally, the Java Virtual Machine is an incredibly battle-tested piece of software that can easily handle size and scale and all kinds of workloads thrown at it. This is an important thing in the era of AI swarms. So don't take it from me. We're seeing examples like this every day where organizations are once again betting on Java. Now, where do they start? Well, in order to hear a little bit more about that, I'm going to hand things off to Anna and Lize from the Java Developer Relations Group in order to talk about how you can take advantage of Java today for your AI-enabled agentic applications.
Wow, that was very nice. Wow, AI is a word that means so many things. AI is coding assistants that help us learn, write code, test that code.
Or AI in the form of LLMs and agents that we integrate into our products to enhance business processes, add new features, or enhance user experience, although opinions diverge a bit on the latter one.
Or training machine learning models to get better or faster in predictions in order to get better results tailored to our own domain of interest.
So in Thursday morning community keynote, we will be covering coding with AI assistants. But in this keynote, we want to see how to extend our code with machine learning models, LLMs, agents. So we will cover training models, running models, which is called inference, and how to build it into bigger systems.
All in Java, so we don't need to leave our stack behind, and all in all, we can still benefit of Java amazing features that were earlier mentioned by our leadership. So,
a little bird told us that Uber has been training many machine learning models and been integrating them into their Java backend. So we're very curious to learn more. Please welcome on stage Zhitao, Director of Engineering, AI, and Mobile Infrastructure at Uber. Welcome, Zhitao.
Thank you, everyone. I come from an org called Michelangelo, which is responsible for all the end-to-end machine learning and AI development for Uber. We have been doing machine learning for almost a decade. And guess how we run these models and what language we use? Of course, it has to be Java. Why is that? We want to make sure the stack stays always reliable with many nines of reliability. We need to scale to accommodate all the different markets across the world. We want to make sure the transportation, food delivery, and all other gig economy offerings we offer are 24/7 available, because people's daily life and people's job security are all relies on it. We have been using Java to run our model for almost a decade at this point. And with this amazing platform, we are able to run more than 20,000 models trained every month. We serve more than 5,000 models. And at the peak, we perform more than 40 million of model predictions per second. And the reliability, predictability, and the great efficiency of Java allowed all of this to be centrally managed by a team of less than 10 engineers. This offered great central upgrade possibility, keeping everything secure, keeping everything efficient, and allow us to smoothly upgrade through JDK versions. That further brings a lot of efficiency and cost optimizations, making sure we self-sustain the business, and our cost of AML is growing slower than the business values we grow. That everybody will love it. But now, AI is hitting us. When AI hits us, the model needs to scale. We literally have customers telling us we need to grow our models more than 300x in the next 12 months. Yes, it's 300x, not 300%. How do we do that? The answer is simple. NVIDIA GPUs. We need to put the GPUs into our Java-centered platform to keep running this model at scale. It turned out, with all the great offerings from NVIDIA, these GPUs offers excellent scalability and performance improvement. That includes using technology like Triton Inference Server, which is one of the best model server to run large-scale models on top of GPUs. That includes TensorRT. That is how we optimize the GPU serving to the highest level of optimization. So we get the best latency and highest throughput. That also includes technology like multi-instance GPUs, which we're actually making this GPU a fractional virtual pieces. So we can fit all sides of different models and let them getting accelerated by these GPUs in a very efficient manner. But all of this create even more pressure to our Java process. We are seeing 10 to 100x increase on the request per second to every single JVM instance we are seeing once we put the GPUs inside. In order to do this, we have to look at innovative design patterns to disaggregate the serving of the CPU side, which runs on JVM, and the GPU side, which runs on the NVIDIA technology stack. We also need to do a lot of deep tuning of the JVM stack in order to making sure the number of threads are matching the CPU cores. The garbage collection is optimized to the best so that we can keep meeting our latency goals and availability goals. We are very pleased that even if we put so many large-scale models, we are still able to operate this incredible fleet of model servers on many different centers in the world and serving all the companies, all the markets in the world, meeting our previous SLAs and the latencies. My colleague will be here tomorrow to give a talk about how Uber's model team and Uber's Java platform team work together to making sure this impressive platform works together. So if you want to know some very practical tricks and the knowledge of how you run Java and modern AI at scale, please come here tomorrow at 9:30 a.m. and listen to the talk. So in a nutshell, if you want a world-class, reliable, low latency, hands-free, operatable system of AI, please keep using Java. And if you need to scale it, look at NVIDIA. Now let me welcome my friend at NVIDIA to talk about what they're doing here.
Zhitao. That was an amazing scale-up story, and it really teased things up for me. I am so happy and thrilled to be here today. I am Ikroop Dhillon, and if I go back to about 18 years ago, I was early in my career, and I had just joined Sun Microsystems, and I was on my way to a Sun Tech Days, and in 2 weeks, I was presenting to hundreds of Java developers about how to profile and debug JNI applications. Right? So aren't we all grateful for Project Panama? Because that was challenging. From there, my journey led me to NVIDIA, where I am so fortunate. My mission is to work with Oracle to bring the full value of the NVIDIA stack to Oracle's applications. So we have been partnering with the Java architects at Oracle for many years around Project Panama, and I am excited to share some of our work with you today. As many of you know, NVIDIA has been pioneering accelerated computing and AI. In fact, the NVIDIA GPU Technology Conference is taking place as we speak in San Jose. Yesterday, our CEO, Jensen Huang, gave the keynote address. He talked about many innovations in AI, everything from accelerated data processing to our frontier Nemotron models, to how we are partnering with OpenClaw to make it enterprise secure, to our computing infrastructure. Chad said Java powers the world, and I will add, the world's AI runs on NVIDIA. We have thousands of companies and startups that we work with. Our ecosystem includes millions of developers. Java historically has been focused on CPU-based enablement, but today's modern HPC architectures and the ecosystem is much more complex. There is a lot of acceleration available and a tremendous amount of value to be derived from your existing Java assets. So at NVIDIA, when we think about Java, we think about how do we enable Java to take advantage of this ecosystem. 80% of NVIDIA is focused on software development. We have over 2 times as many software engineers as compared to hardware engineers. We have hundreds of libraries and SDKs. Here you can see the entire value of the NVIDIA ecosystem. Hardware is just the bottom 2 layers. Software is the top 3 layers. And that is where we bring value to Java. To understand where AI is going, we have to look at the data feeding it. The demand for compute and data is growing at an absolutely incredible pace. Structured data is the ground truth of AI. It's formatted, it's searchable, think databases, right? Unstructured data is the context of AI. It captures the human language, emotion, nuances. It really captures the why behind the what. So think emails, videos, documents. And unstructured data makes up 90% of enterprise data. So this brings us to how are we accelerating massive scale data processing for the Java vector search ecosystem? NVIDIA cuVS is our library that is making this unstructured data, this vast amount of unstructured data, useful. It powers vector indexing and search in the world's largest vector stores. And vector search allows you to search for data based on similarity rather than exact keyword matches. So it converts your unstructured data into numerical representations. The vectors are then stored in a vector index, and then you can search. You can perform proximity calculations to find similar items. And it is the core technology powering RAG. It's used in chatbots, used in recommender systems, used in semantic search interfaces. For example, you could think about the media and entertainment industry, where you have millions of hours of video footage. You can now convert this into a vector embedding, store that, and then search for all of the frames which may have an animal in them. So this process would take hours. So it now takes minutes with the acceleration. So for the Java ecosystem, we have created open source wrappers and plugins to enable Java to take advantage of this natively. And this is through cuVS Java and cuVS Lucene. cuVS brings transformative performance leaps. So we're seeing 6 times faster end-to-end indexing speedups, about 12 times faster search, and it allows you to really scale up. So you can scale up to billions of vectors. You can process millions of vectors in just a few minutes. And this level of performance is what is really needed for agentic RAG. So when you have hundreds of agent requests hitting your vector database simultaneously. Now that you have the data, we need to action on it. So to help you build out these advanced pipelines, we provide the NVIDIA building blocks for AI. This includes our NVIDIA NeMo services, our frontier Nemotron models. And Nemotron models are not just a collection of models. It's really a suite of open source AI technologies, open weights. We have open training data, the recipes. We share all of it with the world. Nemotron 3 Super is our model that we released just last week, our 120 billion parameter model. on the leading edge for agentic AI for reasoning. Nemotron VL is our vision language model, heavily used for document understanding in the enterprise. Nemotron voice chat is our speech-to-speech model, which understands human dialogue, the nuances in human conversation, knows when to pause, knows when to pick up again. So together, these tools and the models unlock deep understanding and reasoning. And we also understand enterprise needs, and that is why we've created NIM. NIMs are our containerized, optimized models. So we optimize our Nemotron models as well as popular open source models. So any model that you know and love, you can leverage through a NIM. And here's where it gets exciting for Java developers. Our models and microservices interoperate beautifully with the Java ecosystem. So they're set up to work with Spring AI, LangChain4j, and Babel. So NVIDIA NIM, together with TensorRT and Triton, which Zhitao just talked about, really provide a high-performance inference stack. TensorRT optimizes the models for maximum performance. Triton allows you to serve and scale the models. And NIMs provide a secure way to deploy. And I want to close with just the Java ecosystem. We love the Java ecosystem. You are making incredible strides in enabling developers around the world to take advantage of GPU acceleration. And a perfect example of this is Project Panama. Our team, our cuVS team, was able to come in and build cuVS leveraging the work you've done with Project Panama. And we're exploring additional methods to bring acceleration to Java code through Panama and Babylon. Our goal is to meet Java developers where they are. We look forward to continued collaboration with this community. My colleagues will be giving a talk tomorrow morning where they are going to double-click on a lot of this work, so encourage you to join. Please connect with us, share your feedback with us, and thank you for your time.
Thank you, Ikroop. They're building amazing things at NVIDIA. Now let's go one level up in the AI tech stack and talk about LLMs and agents. The Java ecosystem covers this greatly with, on one side in the Spring ecosystem, we have Spring AI to connect to LLMs and Babel, the Agentic framework. And on the other hand, framework agnostic, we have LangChain4j that allows you to work either with the vanilla version or Quarkus or also Spring or Helidon and so on. We had 2 guests planned, but sadly one of them is sick. Rod Johnson, the creator of Spring and of the Babel framework, sadly cannot be here with us. But Josh Long, Spring's beloved developer advocate, will take over his part and show us an amazing Spring AI demo. Welcome to the stage, Josh.
Please welcome to the stage Broadcom Spring developer advocate, Josh Long.
Good morning, everybody. It's my sense that there has never been a better time to be a JVM developer. We live in an amazing time. So to demonstrate that, I'm going to go to start.spring.io. I'm going to build a new application using security, agentic AI with Spring AI, and of course, observability. I've got some data access as well. And of course, we're going to be using Java 25, which at the time of this recording was the latest and greatest. Today, obviously, you'd use Java 26. So we'll go ahead and bring in the OpenAI model for Spring AI. And then I think we've got everything we need there. I've made the decision about what language I'm going to use, what version, et cetera. I generated that project. I'm going to open it up in the IDE. Let me show you one of my favorite features in Java 25 and later. See that? That's a program that I'm just going to run by passing it to the Java CLI. I'm not going to compile it. I'm going to run it like a script. Yes, do you understand what you just saw? That is the first good Java script, okay? Ever. First one. Amazing, okay? I'm a big fan. So I've got now an application. I've got some configuration to connect to the database. I've got virtual threads. I've got to specify a sampling level for observability, paste all that there. I'm going to take this question from the Hitchhiker's Guide to the Galaxy, and I'm going to ask the AI models to answer that question for me. What is the meaning of life, the universe, and everything, right? And so I'm going to inject the chat client. This is your one-stop shop for all things AI. I'm going to configure it using the builder, just like you would with any other client in the Spring ecosystem. And I'm going to create a simple HTTP controller endpoint here, okay? I'm going to use the AI chat client to do the work. I'm going to create a prompt. I'm going to connect to it. I'm going to ask for the response to come back as a string, and then return that from the controller handler method. Now, obviously, I've got scalability with virtual threads, but I need security. So I'm going to use Spring Security here, and I'm going to set up passkeys. Now, passkeys are an open, it's a productized name for an open protocol called WebAuthn, and it works everywhere. It works on Linux, it works on all the browsers, works on Mac and all the browsers there as well. It even works on Windows, okay? It's everywhere. Now, I'm going to go ahead and specify the loud origins, the host, the name, all that kind of stuff. Now that I've got my security, I also need to specify some usernames and passwords. I've got some in a SQL database. I'm going to specify that here as well. And that's it. That's my application. I want to run the application. And look, to do this, I'm going to make my life easier. I want this to run as quickly as possible. I'm going to do a training run with Project Leiden, right? And get some AOT cache in there. It's going to do a training run. It's going to evaluate what it can cache before running it. And then it'll start the application up in no time at all, about 0.5 seconds or so. And while I'm talking about this, let's talk about how good Java is, right? Java is an amazing language. There's a benchmark that came out, an amazing ecosystem. There's a benchmark that came out about a month ago, comparing Spring AI and Spring Boot on Java to MCP implementations and other ecosystems. And as you just saw, the JVM came in #1. It wasn't even close, right? Better than Node, better than Python, better than Go, okay? Very, very resource efficient, very fast, etc. Now, let's log into the application that we've just built. I want to register one of those passkeys. That has to live, it's public key cryptography, and it's managed by the Passwords app on the operating system. So I'll go there, I'll use my fingerprint to do some security. I've created the passkey. I'm going to log out now, and we're going to ask the AI model via this endpoint, the secure endpoint, to answer the question. It's 42, you saw that, and there's the observability data flowing into our Grafana dashboard as well, okay? Very good. So now we have a scalable, secure, observable, agentic AI system and service in no time at all. And this is the power, I think, of Spring and Spring Boot and Spring AI. Check out start.spring.io for more. Thank you for that. I appreciate that. I hope you got something out of it. Who learned something new out of that? Very good. Good, good, good. Thank you. Now, my good friend and the amazing, the inimitable, the legendary Dr. Rod Johnson could not be here today, so I'm going to cover his little section of the keynote as well, and we're going to talk about Mbabble. Now, Mbabble, you just saw how Spring AI makes it easy to build agentic systems and services. You might have thought, well, in order to do anything more advanced or more interesting, is that screen up? Here we go. In order to do anything more advanced and interesting, I might need to dip into Python. No. Quite the contrary, right? If I want to build agentic systems and services, there's no better place to do this than on the JVM. And so I'm going to use Mbabble. Remember, when you orchestrate multiple LLMs, that's an integration problem, okay? It's an integration problem. And other frameworks like LangGraph solve this really inadequately using the state machine. It's very inflexible. Instead, Mbabble uses GOAP, goal-oriented action programming, to, in a deterministic way, without using LLMs, to create a plan that you can then arrive at deterministically and with strong types. It's a very, very natural, elegant alternative. Mbabble also offers, there you go, there's Mbabble. Mbabble also offers a very, very easy integration, like I said, with GOAP. Okay? And it also helps with something called dynamic tools or unfolding tools. The idea is that when you talk to an LLM and you give it too many tools, it consumes too much token count and it becomes more confused. The response is less accurate. Mbabble offers something called unfolding tools, which allow it to dynamically discover the tools that are available to it, so that if and when it decides it needs it, it can use those. You call a tool, it unfolds another tree of tools that it can then decide to use. This is much more elegant and allows you to effectively use as many tools as you want without getting a loss of accuracy or paying the context penalty. Okay? So Mbabble is all about agentic enterprise-grade AI in Java and on the JVM. My friends, look, there's never been a better time to be a Java and Spring developer. We're not catching up. This is far ahead. The things I just showed you, the agentic RAG support, the unfolding tools, these are things you're not going to find in other frameworks that are not on the JVM, right? There's never been a better time to be a Java and Spring developer. Thank you so much, everybody. Have a great day.
That was an impressive presentation, and I think was all human-made. So that's impressive. But that's always the case with Josh. Thank you, Josh. Amazing. Now, let's get back to our old pal AI. Well, actually, new friend. When reading about AI, we've all seen a lot of things that are getting hyped, but not all of them are bringing real value. So we thought to give you a starting point and inspire ideas for how to work with the rich Java ecosystem when building AI applications. Without further ado, in other words, we used a workflow inspired from reality about a medical appointment application that we have in the slide here as training ground to design meaningful AI capabilities. Patients submit help requests via the user web-facing app, which arrive at the help desk, where operators manually triage them, flag urgency, and do much more. But all this is a time-consuming process. And if you add high ticket volume, an unavoidable responsiveness gap gets created. So let's close this gap. We started by understanding where each part can help. AI is great and is capable of taking over 90% of classification of the help request tickets, enriching tickets with more relevant information from across the company, or creating small code fixes for specific issues, or flagging urgency for those tickets. But humans, they stay highly relevant when the system needs accountability, judgment, or change management, especially as we know, AI output can be wrong, ambiguous, but also can have a high impact in our enterprise systems. So next, in order not to deteriorate the experience of the end users that are using the web application, but also the folks that work at the help desk, the initial system got extended. Help desk first calls the AI triage service to classify and route the ticket with an AI confidence score. If AI triage responds with a confidence below a certain threshold, then the request is routed to the human review queue. AI triage, furthermore, enriches the ticket by calling the urgency service to generate a priority score from a domain-trained machine learning model. Then it performs semantic search on the ticket via the similar tickets service. And lastly, the company document service is called to check on the policy knowledge-based citations that are available for a specific role that called on that. So AI triage classifies the ticket by type, urgency, confidence to the help desk, which dispatches the ticket to a mapped human team. But we went a little further. So when AI triage agent is returning a bug, for example, upon classification, that bug gets dispatched to the coding assistant to maybe propose a fix for us. So Lize, now let's take it to action.
All right, so we wanted to demonstrate a couple of enterprise AI patterns in Java. Let's start at our user-facing app to book medical appointments. We're a user and we have a question for support. I tried paying 5 times with different cards and all of them failed. Now let's go have a look at the backends. So here we are in the help desk ticketing system, which is built with Quarkus and MySQL. And as we see, this ticket has come in. We have the logs to see what's going on. And it is sent to AI triage. AI triage is a Quarkus service using LangChain4j to connect to OpenAI's GPT-4o model in this case. But in Java, it's a super easy swap, 2 lines of configuration to, say, call a local model instead, or connect to NVIDIA NIMs. That all works. So first thing AI triage has done is assign this to a team and a category, a billing category. And as we can see, it has also added an urgency score critical. Now, this was this urgency service where we use a model that we trained in Java with the DeepNets library. Now, why did we train a specific model and did we just ask the LLM? Because when a ticket is flagged as critical, it is actually for us business critical. In this case, multiple payment failures, our payment system might well be down and that's going to cost us a lot of money. An LLM would maybe have given us another score, so we really train on our domain knowledge, on our old human-rated tickets. What else did it do? It added a whole bunch of similar tickets. That's very interesting for the help desk employees to see how similar complaints have been treated in the past. For this, it called a similarity RAG service that we built with Halidon and Oracle's 26 AI database, which is extremely suitable for handling large amount of vector embeddings and searching in there. It also came up with a bunch of related company documents and policies that might be relevant while trying to deal with this ticket. This service is built with Quarkus and Docling. Docling is a very interesting text or even document preprocessor by IBM. And what it does is it can even handle complex documents like PDFs with tables, with graphs, and actually encode the information from these tables and these graphs as well into our RAG system so we can search in it. As you can see, it didn't give back a summary, like some invented AI summary based on some chunks. No, we give back real citations. That's also an enterprise pattern because we want our help desk employees to act on real information. And furthermore, when you look into the original document, you see these citations highlighted in the text for extra context. So this ticket was triaged with all that extra information in under 2 seconds. That's really smooth. But I want to show you something else. If we're going to report a bug, for example, when clicking confirm appointment, I get a crazy 404 error page. Happens to the best of us. This is going to come in and should probably be classified as a bug. There we go. So under 2 seconds, it's already classified. And since it's a bug, we call our coding agent. The coding agent is a Quarkus wrapper around OpenAI's codex. And so we see the ticket come in. It checks out our repository. And the first thing it's trying to find is the likely bug cause. Let's see if it gets there. So this runs a little longer. These agents can run from seconds to minutes. And that's where Java's concurrency features come in really handy. It's taking a little longer than usual. Yeah, there we go. So it found a likely bug cause for this complaint. And it also gives this confidence score. When it's not really confident, nothing else happens, simply. But if it's confident enough that it knows why the bug is there, we ask it to fix it and create a pull request. So now it's fixing it. The whole Git checkout and everything happens in Java, and it's done. So we should now be able to see this pull request on our ticket. There we go. Let's have a look. Yes. So we have a pull request with the original complaint description, the likely cause, the fix summary, and the actual fix. Things are a bit slow today. Yes. So there we go. Very nice to get your tickets already prefixed, right? Now, very important for also enterprise AI is that a human stays in control of final critical actions, such as reviewing and merging this pull request, or even the ticket itself is an AI-generated ticket. We say that a human has to accept this before it really enters into the workflow. So we treat AI as suggestions, helpful suggestions, but the human stays finally responsible for accepting anything AI generated. And then one last trick, very important to save your nerves and a lot of time. If you're not happy with what AI outputted, it has to be easily revertible. So if we don't like this ticket, we can click here, boom, and this complaint goes just back into the human review queue, and we don't have to deal with undoing AI slop. So that were a whole bunch of machine learning, LLM, and agentic concepts together in an enterprise application in Java. We hope to show you that you can, with good engineering, create real business value with AI while keeping the humans in control. If you're interested in this code, it's public. You will be able to scan the QR code that is going to be back with Anna's slides. Back to Anna.
Thank you, Lize. So the QR code will take you to the entire system that will probably evolve. As many people know, as developers, we're never happy with the code. We're continuously trying to improve it. So we showcase patterns of how you can adapt real workflow with, let's say, troubles into real business value, but in a controlled way, without leaving Java. Structure responses map directly to Java types in our case, and those enforce cardinals instead of just parsing three texts to the AI. Then we have used pretty much retries, circuit breakers, tracing, and async workflows. These are patterns that us, the Java developers, already know and we already have employed in our systems, right? So this can also help us further to make high latency AI reliable. Thirdly, the existing security libraries, audit logging, and compliance infrastructure that is available in Java, those apply directly to AI interactions too. And fourth, from training libraries like DeepNets to inference with DGL and agent frameworks like LangChain4j or Spring AI, Java can support the full AI lifecycle. But all these efforts that we showed today couldn't have been possible without a great foundation, the Java platform. To tell you more about the innovations inside the Java platform, we invite on stage Paul Sandoz.
All right. I prefer the light theme, not the dark theme. Okay. So Java is often where AI needs to be. To me, that is uncontroversial. If I said that at a machine learning conference, I might get a few eye rolls from people. But I think we can make a stronger claim that Java is almost everywhere AI needs to be. Those folks at that conference might laugh and jokingly tell me to get my coat. But they do have a point. But Java is in a stronger position than many might believe. Let me explain. Consider a machine learning model. It is the central software unit of any machine learning system. It is essential, but it is not enough. It cannot function in isolation. So we need surrounding code to make it work inside a larger system. For example, code that converts text to tokens, which are then input to the model. And as the system grows, there will likely be many models, some small, specialized, running close to applications. Others large, general, powerful, operated as a service requiring specialized execution at scale. Within this large system of software surrounding these central software units, we encounter Java, almost everywhere. Java connects models to information sources, such as relational and vector databases, enabling models to respond more accurately without constant retraining. And more generally, Java orchestrates the interaction among models, tools, and information sources to autonomously achieve a goal. This central software unit, this machine learning model, is only a tiny fraction of all the software required. Much of that additional software is connecting things together reliably, at scale, in production, the costs of which are maintainable over many years. Java excels at this, which is why I think Java is almost everywhere AI needs to be. And I think this conference supports my claim. We already heard from my colleagues, Anna and Lize, that Java is an excellent platform for developing agents. And with each new release, Java gets better, which means applications and libraries get better. 2, Helidon, LangChain for J, Spring, and Babel, and so on. Java 26, released today, happy St. Patrick's Day, by the way, is no exception. Java warms up faster with Project Layden's ahead-of-time caching of program behavior, and now that works with any garbage collector. Java code runs more efficiently with enhancements to the G1 garbage collector, and Java code written with new pattern matching features is easier to read for humans and machines. Those are just a few examples. Java 26 contains many more, as George said. To get a sense of that, I asked a colleague who works on the hotspot compiler what they thought was their most important contribution to 26. They said, enhancing the JIT to check for array aliasing at runtime in order to enable more auto-vectorization, which means that loops over arrays run much faster. The engineer, Emmanuel Peter, also wrote an excellent blog post if you want to know more. This is just one example of the many improvements that are not obviously visible, but collectively improve developer productivity and program performance. So yes, Java 26 is a great release, but I am not satisfied with Java being almost everywhere AI needs to be, because the models themselves are not written in Java. Most models these days are Python wrappers around C and C++ code. Can we do better and connect Java closer to the model, or even write the model itself in Java? I think we can. So instead of this, we can enhance Java and make that stronger claim true. How might we go about this? Last year, on this stage, Java's chief architect, Mark Reinhold, gave the JavaOne keynote. He eloquently explained why, after 3 decades, Java remains, and I quote, one of the most popular programming platforms in the world, used by millions of developers to build mission-critical systems for organizations large and small. Mark explains part of the answer as to why Java has been successful is our relentless focus on developer productivity and program performance in the face of constantly evolving demands on the Java platform. And we're seeing this now with AI, which demands new ways to represent Java code, process large amounts of data, leverage native machine learning libraries, and execute on different kinds of hardware. So with this in mind, how shall we go about enhancing Java and get closer to that central software unit, the machine learning model? we look for pain points. Pain points lead to solutions proposed as new features, surfacing up as JDK enhancement proposals in the OpenJDK community. Some pain points are so acute and some solutions are so involved that we create entire new projects for them in the OpenJDK community. To see what I mean, let's look at 2 pain points related to Java and AI. Using GPUs is too hard, and developing machine learning models is difficult. We want to leverage the vast performance advantages that GPUs offer, and we want Java to be a great platform for machine learning model development. But today, it's too hard. It's possible, but it's just too hard. Developers may be forced to write code in a different and probably lower-level language, for example, OpenCLC or CUDA-C, and embed that code in strings or text blocks in their Java program. Or they may be forced to write unnatural-looking Java code that is hard to read and hard to maintain. How shall we, as stewards of a Java platform, address these pain points? We identify foundational building blocks in the JDK. Then we use those blocks to build libraries that, for example, leverage GPUs. And then we use those libraries to write Java code that runs on GPUs. The JDK foundations are protected. Our efforts to gradually ensure integrity by default of the JDK means we are free to change the JDK internals at will without breaking libraries and applications. In Java 26, we are gradually ensuring, finally, that final actually means final, restricting final field mutation, woohoo, which will make Java programs safer and potentially faster. Library developers cannot descend into the basement with their power tools, I'm a library developer with power tools as well, and undermine the foundation's integrity. Those same protections are also afforded to libraries if they so choose, ensuring applications cannot undermine library integrity. After all, who wants to maintain their internal APIs as if they're public APIs? The end result is a beautiful, stable tower of software written in Java. The pain points I mentioned, that using GPUs is too hard and developing machine learning models is difficult, are so acute that we created Project Babylon. Project Babylon delivers part of the solution, a foundational building block whose pain points have in common is the need to translate Java code into another language, to translate Java code into code of a foreign programming model, something that is not the Java programming model, such as Java code to GPU code, or Java code into a machine learning model. Let's explore further and consider our first pain point: using GPUs is too hard. Here is some ordinary looking Java code. It represents a GPU program we call a kernel. It squares the integer elements of an array. It's the kind of natural looking Java code we want to write. It's also a natural looking Java code that might be familiar to a GPU programmer. We want to translate into an equivalent GPU program written in CUDA-C, which is a dialect of C for representing GPU programs running on NVIDIA hardware. We certainly don't want to jump all the way to the right-hand side and write our C program and embed it in a text block in our Java program. How can we do this translation? We do so by using features of Project Babylon. First, we reflect over the Java program not only the surface details of the methods, which we can do today using reflection, but deeper to include the Java code contained in the method bodies. This deeper form of reflection yields an in-memory representation of that Java code we call a code model, which is a bit like an abstract syntax tree. Second, we translate the Java code into an equivalent CUDA-C program. What I've just described is Babylon's first feature, code reflection, a platform feature that lets us reflect over code below the surface of the Java program, yielding code models which can then be translated. More abstractly, the Java code on the left is described by the Java programming model as specified by the Java language, the virtual machine, and the APIs. And the code on the right is described by a foreign programming model, one that is unknown to the Java platform. In our example, this foreign programming model is the CUDA programming model specified by NVIDIA. The JDK does not and should not know about that. It's the Java library providing GPU support, that middle part of the tower of software I showed earlier, that knows about the CUDA programming model. Now, Project Babylon's code reflection is a necessary feature, but insufficient on its own to fully address the pain points. We need to do something with that CUDA-C code. Babylon needs a colleague, one whose features are already present in the JDK. That colleague is Project Panama, and they have a very close bond. We can think of their relationship like this. Project Panama is to foreign libraries as Project Babylon is to foreign programming models. The features provided by these two projects provide the foundational building blocks to build that beautiful Tower of Babel I showed earlier. Returning to our example, recall that the CUDA-C code now presented on the left was produced using code reflection, reflecting over the Java code and translating it. Now, using Panama's foreign function and memory API, we call the foreign CUDA-C compiler and compile our CUDA-C code. Then again, using Panama's FFM API, we call the foreign CUDA runtime to execute the compiled CUDA-C code on the GPU. What I've just described is Babylon's second feature, a library called the Heterogeneous Accelerator Toolkit, or HAT for short. With HAT, we can write Java code, debug and test on the JVM, and then run it on the GPU for performance. Okay, now for a fun example. Some of you may know about ShaderToy, a fascinating website where developers can build and share programs called shaders that produce stunning visual effects. A shader is a special kind of kernel written in the OpenGL shading language. And here we see the ShaderToy page for a shader that produces a weird truche effect. My colleague Gary Frost, the architect of HAT, was inspired enough by ShaderToy to extend HAT's programming model so shaders could be written in Java. This does not have much to do with AI, unless you perhaps ask an AI to generate a shader, but it is fun, and it's a strong visual demonstration that using Java and GPUs can be easy. We can write the truche shader in Java with HAT, like so, and then we can run it on my laptop at 200 frames per second or more. If I run it instead on my laptop's CPU using parallel streams, I get a twitchy 25 frames per second and a hot laptop. We have seen how we can address the first pain point, that using GPUs is too hard. And now at a higher level, we need to make it easier to develop the models written in Java, which will leverage all those GPUs, which leads us to our second pain point. Developing machine learning models is difficult. Last year at JavaOne, Mark and I talked about learning to crawl, using Java and Project Babylon to write a machine learning model that could predict a digit in an image, using Onyx, an interoperable format for machine learning models, and a runtime for executing them. Over the last year, we progressed from crawling with a simple convolutional neural network to taking our first steps with LLMs, and now we are happily toddling around with stable diffusion models. Here is one example involving 3 actors: a bespoke Java agent, an LLM written in Java, executed in Onyx runtime using Llama 3.2 1 billion weights, and a stable diffusion model, also written in Java, executed in Onyx runtime using ST turbo weights from Stability AI. The Java agent sends name 5 photograph places to the LLM. The LLM responds with a list of those locations, and then it sends the first item, Grand Canyon, over to the stable diffusion model, and the stable diffusion model responds with an image of the Grand Canyon, hopefully, cross fingers. Then the agent displays the image, and so on. Let's see that in action with a demo recorded by my colleague Adam Satona, who built the demo and code using Project Babylon and Onyx. And now we see we sent the message to the LLM, it responded back with 5 locations, and then it's going to, whoa, hold on a minute, what's that? There's a penguin in the image. You may have seen it fly by, but what I didn't say was, I forgot to mention, that we appended with penguins to the message it sends to the stable diffusion model. That model is not very good at rendering dukes. It's better at rendering penguins, which are the nearest animal resembling a duke, do you think? Maybe? Well, some of you may reasonably insist it's a panda, and we can oblige. Okay, what I've shown you is a prototyping effort called Java Onyx Script. It's an experiment. With the Java Onyx Script library, we can represent models succinctly in Java and export them to Onyx models and execute them in the Onyx runtime. We hope that one day we can write and train models in Java. Today, that still happens more often in Python, which leads us to one more pain point. Using Python libraries from Java is too arduous. The pain is acute enough that we are recreating Project Detroit. Detroit was initially created in 2018 with the intent to develop an implementation of a JavaScripting API based on the V8 JavaScript engine. This would enable JavaScript to be used as an extension language for Java applications, but also it would allow Java libraries to be accessed from JavaScript applications. But the project never got off the ground, however. But there is still strong interest in using Java and JavaScript together. And now, with the rise of AI, there's also strong interest in using Java and Python together. So we are recreating Detroit, and we are expanding its scope. Detroit will include a JavaScript engine based on V8 and a Python script engine based on CPython. By using widely adopted implementations instead of re-implementing those languages from scratch, we get lower maintenance costs and better compatibility with existing JavaScript and Python code. To fully address the pain point and leverage V8 and CPython, Detroit needs help from a familiar colleague. Project Panama, of course. Project Panama is to foreign libraries as Project Detroit is to foreign language runtimes. Somewhere in this OpenJDK community was born 3, Babylon, Detroit, and Panama. And if you like De La Soul's hip-hop music, then that's the magic number. Of course, OpenJDK has many more projects, and the number keeps growing. So it's actually more like Wu-Tang Clan, arguably one of the greatest hip-hop groups of all time. Shaolin development style, where OpenJDK and Java are the best under heaven. Okay, back to more serious matters. Project Detroit, like Hat, will be developed as a Java library, and we expect both to push the boundaries of the FFM API. And finally, if you want to look at Detroit code, the OpenJDK repositories for the Python script engine and the JavaScript engine are now on GitHub. Okay, I hope I have persuaded you that with the building blocks we are creating and the libraries we are developing, we can really connect Java closer to or be part of that central software unit, the machine learning model, that is part of a larger system that is connected using Java, and then we can finally say, without blushing, Java is everywhere AI needs to be. Thank you very much. I hope you enjoy the rest of the conference.
Please welcome to the stage Microsoft's Vice President of Developer Relations, Patrick Chanezon.
Hi, everybody. I'm really thrilled to be at JavaOne. This conference has a special meaning to me because it's the first conference where I ever gave a talk 21 years ago when I was at Sun, and I see many people in the audience that I know. So let's talk about Java at AI scale. So I'm Patrick Chanezon. I do developer relations at Microsoft, and with Brian, we're going to talk about how to put all this into practice for Java developers. So the first thing is that AI is really transforming businesses all around. I'm pretty sure it's happening at the companies that you're working at. It's definitely happening at Microsoft and all across the industry, whether people are using it to increase productivity or have better quality. AI is really everywhere. Now, AI rewards the type of thing that Java is really good at. Building distributed systems that are fast, secure, and evolve with time. Now, there's been a lot of conversations in the industry with some angst about about AI for developers. And on my side, I'm more on the pretty optimistic side, like Tim O'Reilly, who talks about like a new superpower. And at Microsoft, we've been using AI to reinvent what developers are doing within the company. And to me, this is really an opportunity for reinventing the job of developers and going higher level in abstraction and becoming managers of agents. So the evolution of that adoption of AI by developers, it started with code completion. That was like 2023 probably in GitHub Copilot. So you just press tab and you have the AI autocomplete your work. Then it evolved to chat, where you're chatting with the AI model. Then agent mode, where you're telling the AI model what you want, and it's working in the background. To coding agents, and nowadays with things like Agent HQ by GitHub, you can assign an agent an issue in GitHub, and it's going to go work in the background. So what is an AI agent? Simple definition is it's a loop with an LLM in the middle that has some tools to do some semi-autonomous work and act on the world. How do you build them and make them productive as teammates as you become managers of agents? For that, you start by needing models. So at Microsoft, we have this thing called Foundry, Microsoft Foundry, that has 11,000 models available. So there you can choose from models from OpenAI or Anthropic or Mistral. You have both closed source and open weight models in there. And we really believe into a choice of models for you to build these agents. Now, in addition to models, you need a framework. So you can pick any framework from Spring AI that Josh talked about to EM Babel to LangChain4j, to which our team contributes to. Developer tools, we're putting GitHub Copilot into every developer tool that you're using. So it's going to be in Eclipse. You're going to find it in IntelliJ or VS Code. Foundry as the platform to select your model. Then you have different ways of running your containers for your apps, whether you want fully managed with Azure Container Apps or functions, or whether you want to manage them yourself in AKS. And a big data layer where you can have SQL, Cosmos DB, or Oracle, as well as a new layer that is called Microsoft IQ, which is a semantic layer on top of all your Office data with Work IQ, your analytics data with Fabric IQ, or everything that you're throwing at Foundry to be indexed by it and to be retrieved by AI. So this is the IQ layer. Now, Microsoft is a cloud platform of choice for businesses and developers. There's 180 million developers on GitHub, 18 million apps running on Azure, and Foundry processes 100 of Tera tokens every quarter. There's one more thing that came out yesterday for Java developers in terms of framework, which is the GitHub Copilot Java SDK. It came out yesterday, and you can use that also to build your agent. So you can find that at this URL. So that really came out. Ed Burns sent me an email last night to say, hey, we have this cool thing that came out. Please talk about it in the keynote. So now that we talked about all this, Brian is going to show you how to put that into practice into a demo. Brian?
Hello, everybody. Hey, folks. It's great to be here. I'm going to show you a really quick demo today. It's got 3 parts to it, basically, which is we're modernizing an application, taking an older application, building it into something modern. We're adding some intelligence to the application, and we're also deploying that out to the cloud. So welcome to Duke's Ski Chalet. This is a modern Java web app, Java 25. Spring Boot 3.5, and we've added some intelligence to it through a thing called the Ski Trip Advisor. So you can put in a destination, you can put the type of skiing you're going to be doing, your budget range, and your skill level, and it goes out and it gets weather from a real-time weather site. It calculates what to expect when you actually get to the destination. It gives you some recommended products that you can use, you can get from Duke's Ski Chalet. And it gives you some reasoning. Just bookmark the reasoning. I'm going to talk about why that's important and how we got the reasoning into the application in a little bit. It also gives you a little summary of some tips and a list of products that you could choose from as well. It runs on the cloud, runs on Kubernetes and Postgres. It's running on Azure Kubernetes Service, and it's also running on Azure Database for Postgres Flexible Server, both cloud services that are secure, reliable, and scalable. And we did that because we want to make sure that the actual system will function in any environment. It's all containerized. This is the original application. It's built by a colleague of mine, Yoshio Terada, also a fellow Java champion, who some of you are familiar with. It's intended to be an old legacy application that needs to be modernized. And as you can see, it's pretty basic. It doesn't have intelligence built into it. It runs on JavaOne 5 and struts and a bunch of other things that you really want to modernize. A typical modern, legacy application that needs to be improved. So I'm going to show you GitHub Copilot and how we modernize this. The experience is similar in IntelliJ and Eclipse as it is in Visual Studio Code, which is what I'm showing you here. The first thing I want to talk about in GitHub Copilot is the models. Everyone's talking about how one model's eating the other model's lunch, et cetera, et cetera. I use multiple different models every day, and I switch through them at will from Claude, from OpenAI, and from Gemini. And I can use those inside of my subscription. I don't need a separate subscription for any of those. They're all built into Copilot, and they always have the latest models in there as well. So I'm always going to be working with the best stuff. I can take my context of the current workspace. I can work with it locally. I can work with a background cloud agent. I can also work with a background local agent. And last but not least, I can actually use Claude Code SDK agents inside of my workspace with the current context of the applications. Each one of these things can have its own model assigned to it. So you can have multiple models running simultaneously, working on different tasks inside of your IDE. You can ask questions of the current context. You can use an agent to generate or edit code. And you can also use a rather new feature called Plan, which is just similar to Agent, but it actually has a developer in the middle. And then we have some other agents here that are added as part of extensions. So some of the extensions add their own agents to work with. Also, last but not least, we have MCP tools. So I have 292 MCP tools, which makes it run a little slower, but gives me great context depending on the model I'm working with. So let's talk about modernization. This is the GitHub app modernization, GitHub Copilot app modernization extension. You create an assessment, and the assessment has cloud readiness, Java upgrade, and security issues that it finds that need to be addressed before you can actually improve this, upgrade it, and deploy it to the cloud. Some of the tasks can be run automatically, including Java version upgrade task from 5 to 25. I can just click that, and it'll run till done. Other tasks need more interaction with GitHub Copilot. And here's an example of an upgrade plan that was used with a plan feature. The idea is you create a plan, you review it, you iterate on it, and then you use that as a prompt when you're going to actually generate and build the code. This is a 2,000-line piece of prompt, and it will basically generate everything end-to-end that you need to upgrade. Now we're going to talk about adding intelligence with Microsoft Foundry, ai.azure.com. We're going to look for a model first. We have 11,000 plus models, as Patrick mentioned. We're going to narrow that down by capabilities. So we're going to say the agent supported and reasoning. And we're also going to use a source of OpenAI. So once we've got that, we've got a short list of models we want to work with. And I know I actually want to work with GPT-5 because I looked at this earlier, and I used the compare model feature of Microsoft Foundry. I compared GPT-5 to GPT-4 and Claude Sonnet. And as you can see here, it's a clear winner in terms of quality, safety, estimated cost, and throughput. Excuse me. It has a great context. And importantly, the endpoints for chat completions and responses are supported by this model. And I remember I asked you to bookmark reasoning. So it provides a reasoning summary. Not all models do, and I find that the GPT-5 model produces a reasoning summary that's not too big, not too small, just right for the ski trip advisor. So we picked that model, and I've got one pre-deployed, so I can go into the model that's deployed, and if I'm not sure if I want to use this model, I can use a chat, and I can interact with it, make sure it's going to do what I need it to do. But in this case, I know that it's going to work, so I'm just going to use code. I'm going to use Java for the code. I have other choices in terms of coding languages. I'm going to use the OpenAI SDK and the completions API to get that completions endpoint that the GPT-5 model is capable for. I can copy this code into my IDE and work with it, but I can also take this code and put it into GitHub Copilot and ask it to build a prompt for me. And that's what I do. So I copy the code, I put it into Copilot, and it builds a prompt for me after a little bit of iteration. I use GPT-5.3 Codex for building my prompts just because I find it's a little better than other models for building the prompt. And I use Claude Sonnet or Claude Opus to actually generate the code because it tends to work with MCP tools a little bit better. So it generated a 210-line prompt for me to use. And once I'm happy with that prompt, I can generate the code. And it does most of the grunt work for generating the code. It took a few iterations for the prompt and a few iterations to run and build and make sure everything works. But I got a web UI, I got interaction with OpenAI and Postgres all built in. And I was able to do kind of fun things after that. Like I shared an image of Duke and said, use this for the color scheme, and it figured it out. And it actually even used that image in the app as well. So next we're going to deploy it to AKS. I used a similar process. I just said, take all the code in this context and tell me what I need to do to deploy it to the cloud. And it built a really good prompt using the plan feature. And I specified a couple of services I want to use and specified that I want to use the Azure Command Launcher for Java. And what does the Azure Command Launcher for Java do? I asked Copilot, what does it actually do? And it got it almost right. It's not necessarily a drop-in replacement, but it's a wrapper that goes around Java. So it optimizes your container environment. So when you create the container environment and deploy it, it'll actually use some flags and settings to make sure that that performs as well as it needs to perform. To set it up, all you have to do is inside of your container, the entry point, you just change Java to Jazz, and it wraps around Java and makes sure that the container performs as well as you need it to. Once it was done, I just asked it to actually generate the code that I need to deploy this. It created a Docker file, some YAML files, and a shell script to actually run this. It gave me some commands to actually make it go. It gives me a little rundown of the files and what to expect when I use it. And outstandingly, this actually ran the first time and deployed everything perfectly the first time, which doesn't happen all the time, but that was pretty cool. A little bit about code safety. So this is not part of my code base yet. Before it gets to the code base, I have to review the code over here. I can review each individual change, and I can keep or undo each change. And then I push it out to my repo, which has version control. So having to manage, it's very safe when you're actually deploying and working with Gen AI in this kind of environment where you have version control inside the IDE and then version control inside of Git, in this case, in GitHub. And that's everything to do with the Duke Ski Chalet. So we showed you how to modernize an application. We showed you how to add intelligence to it and how to run it at scale in the cloud, on Azure in this case. That's obviously a really high-level overview. We're going to share the link to the repo later, and stop by the booth if you have any questions.
Thank you, Brian. I saw some people smiling when you mentioned you had more than 100 MCP servers. OK, so once you have built your app, you need to deploy it. And actually, you're not blocked to using agent only for development. There are lots of agents that you can use all across the software development lifecycle to optimize them, operate them, and deploy them. We have an SRE agent, for example, that lots of teams at Microsoft are using. Then at Microsoft, we are in the middle of that agentic DevOps transformation. 93% of the global engineering team uses GitHub Copilot. GitHub Copilot is the #1 contributor to GitHub over the past 18 months, and we have lots of teams using SRE agent. Microsoft runs on Java. That's why we're here today. Microsoft is actually a huge Java shop. We run 2.5 million GVMs in production. So there's a lot of experience with Java at Microsoft, and we're trying to provide a lot of tools for Java developers to build their apps. And lots of customers do, from Starbucks to Daimler to Adobe. Now, thanks for coming today. To get started with all this, GitHub Copilot for app modernization, Langchain4j and Microsoft Foundry, and deploy with Jazz on Azure. That last one, I really love it. When I used to be at Sun, there was this guy, Alex Medrano, that I needed to call for what flag I need to use for the JVM. Now Jazz is just doing it for us. We're looking forward to seeing the kind of thing that you're building with all this. Thank you, and have a good JavaOne.
Please welcome back Chad Arimura.
All right, and that concludes the keynote, but we have one last thing. We've got a couple housekeeping slides. They're going to go quickly, so if you like QR codes, take out your phones. Again, I want to thank Microsoft again. Thank you very much for being a great sponsor of the event. And one quick thing, if you know Josh, he can be persistent, and so I promised him that I would allow him to take a selfie because he forgot to do it. So Josh, come on. Come on, Josh.
Thank you, Chad.
All right.
Come on, everybody. Get over here. People always ask me why I want to take these selfies, and the reason is very simple. I'm going to show this to my daughter, and I'm going to say, see, they listen to me. Okay. Okay, everybody, stand there. Pretend like you're happy. Say Java. 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 Oh, so good. Oh, that's amazing. Thanks, everybody.
All right. Now off with you. All right, thanks again to our sponsors, Microsoft, JetBrains, NVIDIA, Azul, Waratech, HeroDevs, and Web4j. This conference wouldn't be possible without you. I have a couple QR codes. Here's the mobile app. If you don't have it yet, take a picture. You can download it right there. It'll have everything you need to see all of your sessions. We have a hack house, so go to the tent, bring your laptop. There's a bunch of experts that will help you program and do a bunch of cool stuff. JavaOne Run, if you like to run, jog, or walk, which is pretty much everybody here. We'd love to have you at the JavaOne Run tomorrow at 7 a.m. The Mentor Hub, so we have a Mentor Hub with some Java experts that will be available to help you with your career, equipping you with everything you need to know to build a professional career in Java. All right, thank you, thank you. The session grid, go to dev.java/schedule. It's if you want the grid to show all the sessions side by side or on your mobile phone, that's the place to get it. And I think we're coming to a close here. Oh, book signings. Yes, we have some famous authors here who have a limited supply of books to give out, and they have some. They will be signing them. So Tuesday and Wednesday in the pavilion, we have dedicated times for that. So join them there. And finally, celebrate with us tomorrow evening at Devil's Canyon Brew in San Carlos. So again, thank you very much for sticking through it for 93 minutes. We appreciate it. Have a great conference, everybody.
And we're back from the keynote. I hope it was a good one. I have to tell you a secret. I'm actually so busy up here I couldn't watch. I'm here with Billy.
Yes, I'm from the live stream chat, now to the live stream stream.
Did I have you on camera?
Yes.
Probably a mistake.
Probably.
So we're going to be here until Chad Arimura arrives, our special guest from NVIDIA. Until we get there, we're going to comment on a few things that we saw in the chat. So let's do that, shall we?
Yeah. So the first one, I want to ask you because I really didn't know the answer to it. So a question came up about parallel streams. When they're used, is it using platform threads or virtual threads?
Right. Okay. So those are using platform threads, and then usually the follow-up question would be, but why virtual threads are so great? Right. So I think it's important to distinguish between concurrency and parallelism. Parallelism means I have a specific problem that I want to split up into several tasks, subtasks, that then all solve part of the problem and put them back together. And I usually do that to reduce the wall clock time of a solution. And they usually also keep the CPUs very busy with that.
Yes.
Whereas concurrency is a lot of things are happening at the same time, more or less randomly. Like, different requests come in, right? I have no way to manage that. They arrive when they arrive.
Yeah.
And they're also often backend web requests are also often pausing for other stuff, asking the database, asking other service. And so virtual threads are primarily meant for the latter case, for concurrency, for different things happening at the same time that might share some data structure somewhere, but generally speaking, do their own thing.
Yeah.
Parallelism is, and platform threads are the best solution for parallelism because these are CPU-intensive tasks, and virtual threads really only shine when there is frequent pauses. If there's no break, no pause, nobody's waiting for anything, then a virtual thread has no upside. And so, since parallel streams are meant as parallel solutions to problems, they will keep using platform threads, which is also the reason why by no means all thread pools will be replaced by virtual threads, or by structured concurrency even. That will only be the case, in those situations where you do want to farm out tasks in this concurrent environment. But if you do something in a thread, in a stream that does pause, or for other reasons you want to use a virtual thread, then gatherers actually have stream gatherers allow us to have custom operations in streams. And there's the gatherers.class, just like with collectors, which has a bunch of those. And one of them is called, I think, map to concurrent, or map concurrently, or something like that.
So I can't remember all of them.
Yeah, but that one does spawn virtual threads.
Okay.
So if people are interested in using virtual threads in a stream, then that feature is there for. And one reason maybe might be something that is massively parallelized, because maybe your problem works best if you can just say, look, I have a unit of work, and I can just isolate each unit for its own thread. That would just be the simplest way to write the algorithm. But then it turns out you have like 100,000 units of work. Then you don't want to create 100,000 threads.
Yeah.
But you could create 100,000 virtual threads for that. So that could
there's no real upper limit to the number of virtual threads the JVM can handle. Or I guess the JDK, kind of want to talk about it. But yeah, I think also at least a bit generifying it is that sometimes comes up as a question: when should you use virtual threads, when should you use platform threads? And kind of to what you're saying is, it's like if you're doing CPU intensive work, then you want to probably go towards platform threads, where if you're doing things where there's going to be pause times where you're calling other services or anything like that, that's when virtual threads would come in.
But it's important that it's not like this is not symmetrical, this issue, but it's generally not strict either, right? Like if you have something that is really very CPU intense and there's no waiting at all, it runs in a virtual thread, nothing bad is going to happen.
Yeah, nothing bad. Yeah, that's just the biggest issue is if you could maybe run into some sort of thrashing potentially, but that's probably getting into some more of the edge cases.
Yeah. So generally speaking, you can do what you think is best without having to care about what this one corner case. If it's a rare case, then either way it will be fine. The other way around as well. Like if you do something with platform threads and then the thread is occasionally waiting, so you are occasionally ending up blocking an expensive thread, then that's not ideal either. That's going to be the end of the world. Although, as the share of deviant threads increases, like if more and more threads are actually end up blocking, then that will hurt you more on platform threads than if you do virtual threads, and more of them will end up being very CPU intense. I think this case is more acceptable, not acceptable, but this has different impacts, more acceptable impacts than the other one.
Yeah. Now, that said, edge cases and virtual threads, there is one other thing. So you were talking with Michael about all the JEPs that came in JDK 26.
Yeah.
Now, one other feature that was part of Java 26 that was just below the JEP level is a fix to virtual thread pinning. So there was one issue where a potential deadlocking issue almost is where if one virtual thread is depending on the creation of another class and a virtual thread is creating that, but depending maybe on that other virtual thread, there could be a bit of a deadlock issue. But now that is fixed in Java 26 to where if another thread is waiting on class creation, it will just be unmounted rather than remaining pinned. So yeah, that's just kind of part of the process of continuing to improve virtual threads. Like the big one was the unpinning or unmounting in synchronized blocks in Java 24. And continuing to improve on that.
Yeah, and we can also see like the 6 months with Cadence shining here, because it means a feature like virtual threads can be released with the known asterisk that there are improvements that need to be made down the line, but those improvements can come every 6 months, as opposed to, oh no, if we ship it like this now, then it's going to be suboptimal for like 3 years, 2 years, whatever. I think 2 years was very rare. I think except for like the first releases. Ever since I think like 1.4, 1.5, like 2 years was unheard of.
Yeah, it usually got to about 3 years, which I guess that brings us to one of the other topics that came up during the live stream chat, which was whether we should stick with the 6-month release cycle cadence or go to an annual release cadence.
Okay, so I think there are two parts to that. One part is just increasing the time between releases. And I think there's just no good reason to do that. 6 months works really well. As I said, like just we talked about previews and getting feedback and making changes. All of that process would be slowed down if we go to 1-year release cadence. And I struggle to see any upside in that. What is interesting, though, is that this year is the chance, and I'm sure we're not going to take it.
We had two chances. We had last year with 25 and 20. Yeah, we did.
Yeah. So we have the chance to align Java version numbers. So not the release cadence, but the numbers with the year.
Yeah.
And so I think that's a really tricky one. I personally think that there's actually value in that because it makes certain things simpler, more straightforward, right? You talk to maybe people who are not deeply technical, not like deep into Java releases, and you want to point out to them like how old your Java version is that you're still using, maybe get an update. That would be so much simpler. You could just paint like, so we're still running Java, it's 2032 now. We're still running Java 27. When is that from? Well, 2027, isn't that easy? The real problem there is, how do you make it so that we still want to have 2 releases this year, but none of them should sound like it's a major and the other one is a minor. Both of those will be the same level of steps, and it's important to keep it like that. They make changes to the Java language specification. All of that can only happen in major releases. There need to be 2 major releases, and people need to understand that there are 2 major releases. If you do something like 2026 or 03 for March and 09 for September, then one looks better than the other. Like it just looks like, it's still the same major version.
Technically it is. I mean, 27 to 28.
Good point. But it looks like it's still the same major version, but just an evolution. So that would not be ideal.
Yeah. No, I mean, that was one of the suggestions to use the year and month, but I don't know. Personally, I'm a fan of the semantic versioning myself, so I'm kind of happy with the decision. And I think part of the reason also that we didn't do that was it would have gone from like 8 to like 18 or 18.3, which would have been
back in the day,
back in the day when we first went to this 6-month release cadence. So I think that would have been, or I guess it would have been 9 to 18.3.
So it's also interesting. Like this topic was already discussed, and there was like a brief moment in time for like I think a couple of months where this was the intended.
I remember that conversation.
Exactly. So like, and I asked Mark about this. Because somebody asked me about this at JCon, I think like 2024 last year, like the year before last. Wouldn't this be a great chance? And I was like, that discussion was already had. And then, but then I talked to that person a little bit more and thought about it, and then I really started to see the value. Like it's a minor value, like having this alignment with the years, but it's also one that can materialize in a lot of conversation all across a lot of people a long time. So maybe it does add up. So that got me kind of convinced to at least ask. And Mark was like, nope. Well, Mark Reinold, that is. We had this conversation already. And nothing changed, right? Like nothing materially changed. I'm not quite sure whether that's exactly the case because you could argue, but now we are used to 6 months. So this is not like back then introduced like 2 different things, like a lot of different things actually, like the release cadence and preview features and all that. So there's a lot of change in the way Java evolves. And now we stomach all of that and understand all of that. So making this other tiny change, I think, is now cheaper than it was. And okay.
All right.
Any more dramatic questions from the chat?
I think that mostly covers it.
Nice. Okay, so our guests are here, and chat, have fun.
All right. Ikroop, Dhillon, welcome, and thank you again for being a big sponsor of JavaOne and being a part of the keynote this morning. Why don't you introduce yourself?
Thank you, Chad. Thank you for having me. I am so excited to be here, being part of the keynote, being part of JavaOne. I lead developer relations at NVIDIA, so I get to work with the amazing Oracle application teams and really bring the value of the full NVIDIA AI stack to them. That is my mission, helping Oracle be successful.
And the amazing Java DevRel team, too.
Yes, of course, the Java DevRel team. We've been working with them for years. It's been amazing.
So there's one thing that really struck me as something that I didn't know. You talked about in the keynote, NVIDIA being a bit like a huge software company, even twice as many software developers as hardware engineers. And so, I think probably like most people, I've been thinking about NVIDIA GPUs since I was, young, when I used to get these really cool, the Force graphics cards, and they enable your games to do way cool things. But now it's a big software company. Tell us a little bit about that and how that transition has been and what a lot of the things you announced today at JavaOne about the software solutions for developers.
Sure, happy to. Many people don't realize this. We have 2 times as many software engineers as compared to hardware engineers. Developers are so important to us, and we have such a vibrant developer ecosystem. We power thousands of companies, and we really focus on software that is going to optimize your models. We also focus on verticals like healthcare, financial services, media and entertainment. We solve the really hard problems. So we take hard problems, we focus on those, we solve those, and we build libraries and SDKs for developers for those hard problems.
Right.
We have hundreds of libraries.
Super cool. So some things that I caught, NIMS,
Yes.
Nemotron, Nemo, Triton. Do you want to talk about a couple of these things?
Sure. NIM is amazing. It is a way for us to containerize models. So we take the latest open source models. We also have our own family of Nemotron models. We take those, we containerize them, we optimize them. You can think of NIM as your R&D team. So you don't have to spend the resources making sure that this model is going to perform the best on a given set of hardware, and it is secure, enterprise ready. With NIMS, we also have enterprise support. So you can very easily click and deploy those models. They interop with Java orchestration frameworks like Spring AI, LangChain4j, and Babel. Nemotron is our suite of models. These are frontier models. We announced Nemotron 3 Super just last week. It's our 120 billion parameter model. We have models for vision language, which are doing amazing. Nemotron VL for document understanding, enterprise document understanding. That is a huge use case right now. Nemotron voice chat is another one I want to highlight for speech to speech. And it also understands the nuances of human interaction. So when you're interacting with a model, you are speaking to an agent and then you want to say, stop, I'm going somewhere else, and the agent doesn't stop. So it understands that. It brings in reasoning. So very cool innovations with our Nemotron models. We're really leading the frontier there, which is exciting.
And are those open weight?
Yes, they are open weight, open training sets, open recipes. So our goal is really to share everything with the community.
Right. Okay. I think, okay, so in one thing, you talked a lot about the models and using them. A lot of developers think about, when they think about using GPUs, they think, oh, well, I don't necessarily need GPUs because it's the big frontier model shops that use them for training.
Right.
Obviously, we've heard about the amount of money that some of these frontier shops are spending on hardware to train. But actually, I think, as we talked about in the keynote this morning, a majority of the workloads are coming to the enterprise are doing inference on models.
Right.
They're calling models, they're running private models, they're running them on NVIDIA, they're running them on Oracle Cloud. When you talk to enterprises, how do you kind of talk about the difference between training and inference, and how are they thinking about it, and how should they be thinking about GPUs with respect to inference?
Right. So training is hugely important, training your model, getting it ready. Inference is so important for enterprises. We have made some recent announcements with Grok LPUs and how we are integrating those as well. Our software stack also focuses on really optimizing everything. So when you are out there and your model is deployed and inference is taking place, everything runs fast, it scales up, it scales out. Hugely important area for us that we invest in through our compute and our software stack.
Right. And you guys just had a little conference as well here at the same time. I've been lobbying for you guys to change the date because JavaOne is set with the release of Java, but that's okay. We'll allow it. Were there any major announcements made that you want to talk about?
Sure. Yes, we have been busy with GTC this week as well, just down in San Jose. Yesterday, our CEO, Jensen Huang, gave his keynote address where he highlighted just so many amazing breakthroughs in AI innovation. Everything from the frontier Nemotron models I just highlighted to how we're working with OpenClaw to make it enterprise secure. OpenClaw has really taken off. So much usage and downloads. So we are partnering closely with them, making it enterprise secure, everything with our Nemo services and our accelerated data processing stack. Data is the fuel, data is the food, and unstructured data is the ground truth of AI. And structured data is the ground truth of AI, right? And unstructured data gives you the context. Right. And 90% of the enterprise data is unstructured. So we have created libraries for this. CrewVS is one of those. We talked about that today, which allows you to really accelerate your RAG pipelines and gain insights and from all of this unstructured data, which is videos and documents and emails.
Right.
So very interesting stuff around accelerated data processing.
Speaking of emails and OpenClaw, so can you guys keep OpenClaw from deleting all of our emails if it has access to it?
We are working on it.
So you
with
mentioned
NemoClaw.
NemoClaw.
Yes.
I like it.
Yes.
I like it. Very cool. So you mentioned GTC, you mentioned Jensen's keynote. Now, I got to ask, there's a lot of talk out there about the culture of NVIDIA being somewhat different from the normal large company. I've heard that Jensen has 500 direct reports or 40, and you can email him anytime and call him up on the phone. Maybe you can pick up and call him right now. Tell us a little bit about the culture. What's it like to work at NVIDIA?
The culture is really amazing. It's very special. We operate very much like a startup, but we are no longer a small company. We are a large company. But there is there is the spirit of innovation. I'll highlight mission is the boss, right? So, and that's a mantra that we all really live by is mission is the boss. If you want to solve a hard problem, you see your customers facing a problem, your partner is facing a problem, there is some way in which we can innovate. We bring the resources together to make that happen. So we're very cross-matrix as well, right? It's really driven with a mission focus to advance computing and bring value to our complete developer ecosystem.
Very cool. And beyond Java, although we think Java is very, very important, beyond Java, there's a big partnership with Oracle and Oracle Cloud as well. Do you want to talk a little bit about that?
Yes, I would love to. We have been partnering with Oracle Cloud for years. I work very closely with a variety of teams at Oracle. I want to highlight a few things. One is Nemotron 3. So OCI, Gen AI service, partnered with us last week. They launched Nemotron 3 Super on day zero. Day zero launch partner. That was amazing. We have also been partnering with Oracle Database. So the Oracle AI database is accelerated with QVS, Vector Search, which is another great collaboration. We're working with Lighthouse Accounts. We have a blog that just went out on that. Also working with Oracle AI Data Platform, where they've integrated QDF, right? So the full accelerated data pipeline story. Right. And one customer case I'll highlight. We also work with OCI to bring our NIMs and our SDKs and all of our libraries to the OCI console. So when you go on to OCI, you can pay as you go. So you can come on, get a GPU, then pay as you go and take advantage of that software. And with Sky TV, we have worked with them. They're adopting QOpt, which is a routing algorithm to optimize routing for their EVAN fleet seeing just 1,000 plus in terms of performance gains.
Right. All
faster
on Oracle
routing.
Cloud.
All on Oracle Cloud with NVIDIA technology. So
very
amazing.
cool. And probably some Java there too. So we talked about a lot today. If developers are interested, where can they go and get more information and get started with some of this stuff?
Yes, build.nvidia.com is a great place to go to get started with our NIMs, all of our optimized models, and Nemotron as well.
Okay, great. Ikroop, I really appreciate it. Thank you for your time, and thank you for being a part of JavaOne this year.
Thank you, Chad. Always a pleasure.
Yeah.